Good morning, everybody. Can people who are outside come get in so that we can start? So as usual, we are going to start with a prayer. So that because we need blessings from God, so that everything can, so that our plans can be smooth. So let us stand up for prayers. Thank you. Barandine, can you please help us with the prayer?
Mana yacu Imana ikomeye tugushimiye ko waturinze ukaba utugejeje hano tugihumeka umwuka w'abazima tweretse gahunda z'uyu munsi zose kugira ngo uzubane natwe zikorwe kandi tuzikore twubahisha izina ryawe byose tubisabye Yesu Kristo umwami wacu amina dawe uri mu ijuru izina ryawe ryubahwe ingoma yogere hose ushaka gikorwe munsi nkuko gikorwa mu ijuru ifunguro ritungura iduhe none twari ibicumuro byacu nkuko natwe tora abaducumuyeho ntutane mu twoshya ahubwo dukize icyago amen bazina bacu batagatifu mudusabire ku izina ry'Imana data.
Okay, thank you very much. I hope that you had a very good sleep and that you are now more energetic for today's session. Today is going to be our last day for this conference, and I hope that it is going to be the most exciting one. So we are going to proceed as done previously. Then in the end, there will be closing sessions, and at that time we will tell you what we have planned as part of the closing sessions. So for now, I want to invite the first speaker, who is Dr. Chibuweze Godwin Aki from University of Ibadan, Nigeria. Dr. Chibuweze is a Nigerian citizen currently residing and working in Ibadan city in Nigeria. He is a lecturer in the Department of Civil Engineering of University of Ibadan, and his research interests are mainly in the area of water resources and environmental health engineering, and has published extensively in this area. He will present physically a research work entitled Integrating the Principle and Practice of Remanufacture into Civil Engineering Education as a Public Health Engineering Strategy for Medical Waste Reduction. Dr. Chibuweze, you are welcome to start. Thank you very much. And since I will be also taking care of other duties, associated with this conference, I want to invite Dr. Kentayo to come here and take over as the moderator of this conference. Thank you.
Thank you. Good morning.
Hello, Dr. Achi. You have 20 minutes.
20 minutes. Okay,
Yes.
thank you. How does this work? All right, okay. All right, good morning. So today I'm going to make a presentation on titled Integrating the Principle and Practice of Remanufacture into Civil Engineering Education as a public health engineering strategy for medical waste reduction. So here, this slide, you notice the logo down there, which is the logo of University of Strathclyde. So we have some collaborators from there. All right, these are my presentation outlines. We look at the concept and meaning of remanufacturing, the process of remanufacturing, the general application of remanufacturing with regard to healthcare, automobile, electronics. Then look at the benefits and advantages of remanufacturing. Then we'll link remanufacturing and sustainable development goals. Then look at the public health and environmental engineering, which is an important arm of civil engineering. Then look at the needs and barriers to medical equipment remanufacture in most developing countries. Then look at the way forward. All right, so here we'll try to describe, to define the meaning of remanufacturing. So this is more like a follow-up on the presentation made by Professor Kuka on the first day of this conference. So remanufacturing is the process of rebuilding a product. So specification of the original manufacturer's products are using parts. Some parts can be new or repaired parts or refurbished parts. But the key thing about remanufacturing is the element of a matching warranty. Because as we go on in this presentation, we're going to see how it differs from recycling and reconditioning. If you notice, I emphasize the word warranty here. Warranty, quality, durability, and performance. That's how it major difference with other terms we are used to. So this is a typical process of remanufacturing. You will see from the one there, you see core acquisition. That's the core now is the main product that has reached the end of life that they wish to remanufacture. So the process of collecting it from the users, then disassembly, whereby you have to open the component into different parts to test each component. You see the next part there, all the way, this is how it goes to the back of, sending it back to the users again. So it's a long process, a very critical one that requires proper testing and cleaning and replacement and testing to make sure it matches with the warranty. So here, the quality assurance is very important. For the quality assurance, like I mentioned, these stages of testing and in line with the standard of a nation, for instance, if it's in Nigeria, for instance, or the UK, there are standards for medical equipment, and these standards are very high. So at each point in time, to ensure that the quality of the products being reproduced or manufactured is in line with the standards. So it has to go through this at every stage of cleaning and disassembly to the final point of assembly and then sending it out for use again. So this also talks about, shows you the process of a typical product. that goes from the material to primary producer to manufacturer, and the users, and until it gets to the point of being thrown away as a waste. So it goes back all the way again to be manufactured. So here, I need to see this, but I don't see. Okay, so here, we look at the major differences in manufacture compared to reconditioning and recycling. I emphasize the word warranties, whereby the compared manufacture to other products. The other products, there's no much warranty on it, which means it's inferior in terms of the guarantee placed on those products. But when it comes to the products that are manufactured, a premium is put on the warranty, which has to match with the original product or even higher. Now look at, it involves greater work to be done, because imagine all these processes I showed before, going through that in a meticulous way. Now look at losing identity. So let's look at a product like a vehicle, a car, for instance, whereby you have to bring an engine from a Toyota car, and you want to replace some parts using a Honda, for instance. At this point, you're not going to talk about the product coming from Honda anymore. So now imagine whereby many components are picked from other components to make up the product. So you no longer, the original components used will no longer be talked about. So then the last part involves the upgrade of equipment to something original or higher than the original equipment. So this talks about the same process and cycle of remanufacturing. Then benefits and advantages of remanufacturing. Professor Coker has mentioned most of this in the previous presentations. So here I'm just going to run through giving you just pointers. The first one, it requires environmental awareness. That's what drives remanufacturing in the first place. Then manufacturing is environmentally friendly because it consumes less energy and less virgin materials. Then it supports the incorporation of green infrastructure in civil engineering projects for sustainable development. And the concept of manufacturing also is very cost effective because you're not going to produce those parts from beginning again. You are still utilizing the original parts. So now, most importantly, now it supports the actualization of SDG goals. The goals 3, goals 4, goal 9, 11, and 12. So let's look at those goals now to see how they actually match with the concept of remanufacture or manufacturing. So if you look closely, you would notice, I wouldn't want to waste your time by going through from goal 1, but I mentioned goal 3, which is well-being, about well-being, good health and well-being. Because in this case now, when we talk about the manufacturing of medical equipment, which I'll get to later, that encourages the availability of those equipment in developing countries. Then quality education, like I mentioned in the beginning of the presentation, we want to integrate this concept into civil engineering education as a concept to reduce wastage. So we look at goal 9, which talks about industrial innovation and infrastructure. That one is very obvious. Then goal 11, sustainable cities and communities. And then goal 12, responsible consumption and production. So you can see how that fits very well. All right, so general application of manufacturing. If you look at the first picture there, you notice this is a car part, a part in a typical engine of a vehicle being remanufactured. You look at the other one, you see that's a phone, a cell phone. In cases where a part probably breaks down, you might have to find another part. You know, in some climes they call it refurbishing, but when you have to pass it through the matching warranty, then that's where it goes to the process of remanufacturing. Then that's the washing machine and a refrigerator. But now let's look at, let's see. So as these are list of those equipment stuff that are remanufactured. Now, in regards to manufacture of medical equipment, This is not very common in our environment because of it's a specialized area, requires higher level of requirement in terms of safety because you are going to use those equipment on human beings. So it's not something that you can just do anyhow, because if it fails, failure in those equipment will result in a very fatal death. So that up there you see, up there you see wheelchairs. Those are simple ones like manufacture of wheelchairs and hospital beds. They don't require so much level of in terms of standard of requirements for medical equipment classification, because there are classes of medical equipment, class 1, 2, 3, depends on the level of how sensitive they are. So the need for manufacturing of medical equipment in developing countries. Recent times, since coronavirus started, we noticed that we didn't really have much of equipment in our hospitals. Ventilators were scarce and other equipment are critical to health. And interestingly, most of the supplies happen in developed countries. So we are left with little. We have no other option than to depend on donated equipment. Most of this equipment, they don't usually meet up to the standard of, in terms of our climate and peculiarity, power outages and issues that are peculiar to our environment, dust, and other issues. So mostly they are designed not so much for us, and also some of them are already reaching the end of their life. So when they get to us as donated equipment, they usually don't last longer than that. So there's a need for this equipment to be remanufactured to delay their stage of disposal and that. Okay, let me just rush through that. So you notice, like I explained earlier, most of those donated equipment end up in what Professor Coker mentioned as equipment graveyards. You see so many parts that are disposed, occupying spaces that shouldn't be. So there's the urgent need, and this happens because we don't have trained hands. Those are familiar with fixing this equipment because of how sensitive most of them can be. You know, if you compare that to a vehicle, if you change a brake of a car or other parts, it can be fatal, but not as much as something like an assistive machine, whereby oxygen fails, the person goes. So that's the level of sensitivity. So lack of trained hands for those that can repair these equipment results in all of them ending up here in a graveyard. So here you will notice this is a continuation of those equipment. See the baby incubators and other equipment in a typical hospital in developing country. So this is equipment for us which we are attempting to remanufacture, but since we are the infancy of this concept, we need to first of all disassemble them to understand how the components work and what they mean, to know they are the ones that we can actually manufacture and all that. So this is the process we are seeing. We just started this work. So you can see that's an assistive machine. You see the oxygen supply in the other picture, the first one there. So we'll see on the stage of trying to understand this equipment. So now I want to look at how we can incorporate this concept into civil engineering. First of all, I need to start with what is civil engineering and what are the specialties in civil engineering. We have structural engineering, we have geotechnics and foundation, we have highway and transportation, we have water resources, and we have environmental engineering. Now let me quickly go to the environmental engineering to narrow down to what I'm trying to show. Yeah, here you notice the different areas of research in environmental engineering. We have area of sustainable water management, sustainable waste management, sustainable energy systems, and then pollution control. There are more other specialties, obviously, but these are the key ones I want to highlight here. So under sustainable waste management systems, you now look at the solid waste and wastewater. So if you go further under solid waste, you now go to the hospital medical wastes and other related kinds of wastes. So barriers to manufacturing in developing countries. I've mentioned some of them before. Lack of infrastructure. We also notice that in most hospitals we lack a database to track the maintenance of this equipment and their age and life and all that. So these details, we lack them. Assuming we had those, will help to monitor equipment and know when each one is due for repair or remanufacture. Then lack of trained hands, of course, lack of expertise, lack of equipment to do the testing, because it's critical to maintain the concept of remanufacturing. We must test. So when we lack those equipment, we cannot really say we are remanufacturing yet. Then, oh yes, I mentioned that. Now, a conclusion now. Management of waste is an essential part of solid waste. So that's how this relates to public health engineering and civil engineering. Then helps to us to actualize our SDG goals, like the goals I mentioned before. There's also an urgent need to integrate this concept into civil engineering curriculum, which we've already started a review. Professor Kuka, Dr. Akintayo, Dr. Labiro, and a few others, we're already having meetings about how to review our curriculum to reflect the contemporary issues in the world. You know, so if we teach students how to design, because when you want to design equipment from the scratch, there are ways you can design them to allow for easy disassembly in the future when it gets to the end of life. So recommendations now, integration, like I talked about, into engineering concept for students in general, also civil engineering students to know the design processes and how to design for manufacturing. So here, government policies. So training of hands, of course, training of hands and people and personnel that can have, more like entrepreneurs, those that can actually individually, their work will be to collect this equipment and remanufacture them. Also train people that will learn how to do it, because the training is an essential part of this process. Then government policies, there's always the need for government will and policies to support the concept in terms of even the standardized system of testing and encouraging people to accept, because that issue came up on the first day, the acceptance. When we were sure that there's a system of testing and standard that's been followed, people will be able to trust this equipment. But when you're not sure, it's hard to really adopt. Thank you for your attention.
And we also thank Dr. Achi for his presentation. Now, do we have questions, or we are satisfied everything is clear about what Dr. Achi presented? I can see a hand. Yes. How many people are willing to ask questions on what Dr. Achi has presented this morning? It's an important paper, important topic, dealing with remanufacturing. I think on the first day of the conference, Professor Koka presented something on application of remanufacturing processes. Now, we want to integrate remanufacturing into our curriculum. So let's ask questions, because the work is still ongoing. Yes, second one. 1, 2. Yes, do we have more? Okay, 3. Not on this side. I want on this side. Probably from a researcher. You've had 2 students willing to ask questions there. Okay, sir. So I'm good. Okay, you've given. Okay, after you, then. Thank you.
Good morning, everyone. Good morning, everyone. So thank you for your good presentation, but I have like 2 questions. The first one, how many times can a product be manufactured? How many times? And the second one, it is just, okay. Like these days, you know, when you follow the news, they are mainly talking about like recycling, only recycling. Like in our country, there is sustainable waste management project, but they are talking about like only recycling them, that waste, not apart from the manufacturing. So I want to ask why they're not adopting to manufacture a product, why? Is it because like it is so difficult, or it is expensive, or it is yeah, that way? Is it expensive or difficult to do other than recycling, or just it is that other reasons? Yeah, that's the questions. Thank you.
Thank you.
Can I take this? Can I take it? Okay. Okay.
Okay, thank you. Thank you for the presentation that you did. So I have like two questions. The first one, I was asking myself, why have you focused on medical equipment, not on construction equipment, for instance? And then for your presentation, you showed the barriers for remanufacturing. I saw different barriers, and I want to ask, do we have some solutions to overcome those barriers? What are you proposing? Thank you.
Thank you. We have 4 questions now for Dr. Achi to tackle. So let him address those questions before we take more questions from my right side.
The first one says, how many times can we remanufacture a product? I would say as many times as possible. So far, at the core, is still functional. So imagine you have a laptop and your speakers stops working, or maybe the body looks old, and somehow you find another body or another kind of speaker to replace it. But when you get to the point whereby the motherboard is no longer working, it means that it's, and you have to solder those components, the ICs and all that. At this point now, you're no longer, it's going to be a lot difficult because you probably end up changing everything. So, but you can still retain some parts because, you know, the concept of recycling talks about breaking a component into separate parts and storing them as parts to be used. But remanufacturing goes beyond that. It goes to the point of utilizing those parts from other components, probably fairly used, new, and testing them, most importantly, testing to make sure that it actually meets the warranty, the standard. That's the key thing. So far that you can go, even if you can go 10 times and make sure that you still meet the standard, well and good. Yeah. So the second one talks about why not adopt remanufacture instead of that most people talk about recycling. That I'll just explain to you now. The key thing about it is, you know, it's kind of tedious because it requires you to follow those steps from collection, opening, cleaning, making sure that it works with the warranty. So people would prefer to just repair something and then quickly go and get another one and dispose of the one they had before. So that's why you see more of recycling and reconditioning instead of remanufacturing. Yeah. So the other one talks about why medical waste equipment. I think the problem, challenge, and the lack of equipment came to the fore during the coronavirus, when we realized in most developing countries the absence of key medical equipment, and at the same time we realized that we had a lot of those lying in storage as stockpiles to be used, you know. Other ones are reconditioned. The cars are not like in hospitals, for instance, in pediatric units, for instance, where you don't have incubators. There's a critical need for incubators in hospitals. But comparing that on the level with you want to fix your cell phone or a vehicle is not as critical as human life. So I think that's reason for our own need, our major reason for looking at that direction now. So the last one talks about, do we have solutions to overcome those barriers? Some of the barriers, of course, we always have solutions to everything, but it depends on whether we're willing to follow the way. Like I mentioned, training. If at this stage now we start training the students and skilled workers on how to understand the principle of remanufacturing, we learn how to work on each product, because you cannot work on everything at the same time. We start small, like using wheelchairs, phototherapy lamps, and stuff like that before we go to higher, more serious equipment. So the training goes on. Of course, there'll be more hands-on experience that'll be gained. Then on the side of the government, if governments should allocate some funding to systems of testing and also the need to adopt this equipment, people will start thinking in that direction. So it's doable, very doable. Thank you.
Thank you, Dr. Archie. We have questions on this. I will first take the students, then Dr. Labion. The students there at the back. No? That gentleman there.
Thank you for a good presentation. My question was the way to make people being attracted by manufacturing product, apart expectation of it's a good quality or its quality, cause African people, they are still have low mentality about the manufacturing materials, and others are not care about environment problem. So some countries, they choose to make high tax charges to outside product, and others provide expositions of that product. So for you, which way you think it is good to make people being attracted? Thank you.
Okay, thank you. Let's have another question there so that we have all the questions together then. Yes, I know. After him, I will give to you.
Okay, thank you. I have to congratulate the presenter for the paper or the research, but I have one question. Is about, we are focusing on manufacturing the product, and you suggested to integrate in the civil engineering education. I have a problem. Are we satisfied with the program taught in our universities about manufacturing? Because I can suggest from my side to focus on the manufacturing practices, and then the remanufacturing will come to complete or to support those programs. This is my contribution about that. Because we can focus on the remanufacturing, and it can be more expensive than to invest in the manufacturing. Thank you.
Thank you very much. Let's have the last one from Dr. Labiron before he addresses all those questions.
Thank you for the presentation. From this, we see that remanufacturing can be applied to all the other areas of engineering. For instance, the people in highways will tell you they are constantly remanufacturing the road. You cannot recycle the road in totality. So you pick a part and recondition it, increase the warranty. Now, in a structure, in a building structure like the one going on outside, how do you give warranty to the foundation? You cannot disassemble the building in the future and work on the foundation. Will you say it is in putting very high factors of safety or over-designing it before we start? Yes, people are asking whether is it worth remanufacturing and why not recycle. And I think in my own opinion, recycling is you take that thing and destroy it to remake it again. But remanufacture, you don't spend too much energy destroying to rebuild. And I think that's the way to go. But as I said, that warranty, will you be able to give it all the time? Thank you.
Thank you for the questions. Dr. Achi.
Okay. Thank you for the questions. I think the first person asked, how can we make this manufacturing attractive and acceptable? So, from the point of view of environmental awareness and in being the steward in issues of environment, some countries, they give credit, carbon credit. Like if your processes require emission of less CO2 and energy, there are credits given to such persons in developed countries. So, for instance, here in a developing country, one could say that if you bring back a laptop or something, a product to a person or to a designated place, there could be some incentives to such action. And also the use and acceptability for hospitals, it will require to work together with the doctors, obviously, to make sure that what is being remanufactured or redesigned meets their expectations. Also, the governments also need to open, like in our country, we have agencies that look at drug and other issues, importations, testing. So when we develop these enabling tools to support the concept of remanufacturing, and people are aware of it, it's publicized on the media, you know, people will likely go for it, and not forgetting that the cost now will be less. The cost of reselling that, and they are sure that it's been tested and trusted. So that, I think, will make it acceptable. So, the next one asks, are we satisfied with manufacturing? Can't we focus on, instead of remanufacturing, can't we focus on manufacturing instead of remanufacturing? Yeah, I think it's easier actually to remanufacture, because if you were going to manufacture, imagine you were to manufacture all the parts from the scratch, from the very beginning, compared to you already have a bulk of an incubator, for instance, that maybe just the fan or the heater or just a component or two has probably rusted or is failing. I think it makes more sense to just bring this equipment, open it up, clean it, test every component, see the ones that have failed, get the ones that, and you can even source locally, because if you have to, like regard with something like an artistic machine, we were informed that the tires, usually, the way they come, usually fail. But we know we can easily get other metals and fabricate something and replace it with what is there that will make it more durable. So it's easier to start with that and understand the concept. I think it's more cumbersome and more demanding from the scratch to make a product. I think so. My own perspective there. And then, how can we give warranty to a foundation of buildings? Okay. So when it comes to when Prof. Coker was discussing, someone talked about used clothes. I think we should try and also put some limitations to products that can be manufactured. That does not mean that a building cannot be manufactured. When Dr. John was making presentation on the buildings that can use plates and bolts, that was designed for ease of manufacturing. When you have concrete that you cannot, if you want to bring it down, you have to break everything down. You end up, maybe you might try to reuse some of the concrete and go through all the process again of testing to make sure that it is usable. But when you can bring down components of a building, it's easier. The foundation also, I can't stand here now and develop a test. There should be tests. If there are no tests, that means that part cannot be used anymore. There has to be a test to say that it meets the warranty for the building. Otherwise, you cannot just use it without knowing that. So warranty is very key to the idea of manufacturing. I think, did I miss anyone out? I think I've tried my best to answer the questions.
Thank you, Dr. Achi. We accept your best for now. and we are looking forward to integrating this remanufacturing in our curriculum. There is a case of manufacture, remanufacture, balancing. And from what I have said, I don't think it's everything that we have to remanufacture.
No.
Some things cannot be remanufactured, cannot go through that process. Am I right?
Yes.
And we just have to discard them. You cannot salvage them. So thank you very much. I hope the universities that are represented here will be thinking along that line. Maybe Ines, University of Ibadan, I know we are going through curriculum review at the moment. Catholic University, another that are maybe part of this conference virtually, they'll be thinking of that. We have to do something in innovation. That is the thing. Thank you, Dr. Achi.
Thank you.
Without wasting any time, I will respond. Yeah, let me first welcome our HOD, Dr. Emmanuel Rotundo. He is there. So he's our host. So, and we are rounding up, so we want the best from him. Let's recognize him. Thank you very much for joining us. The second for the day, we have so many presenters. We have about 8 presenters, and we just had one. So I'm hoping that we'll be able to do 2 more before coffee break. So the second presenter is from Ines, and is in the person. Pardon me, Nahayo. Let me just stop that. I'm sure the person knows himself. Please, can you come forward, Dr. Nahayo? Oh, you are welcome, sir. Dr. Nahayo is a Rwanda citizen with current residence in Musanze City. He is currently a lecturer in the Department of Civil Engineering of Ines, an independent consultant. His research interests are mainly in the area of water resources engineering, environmental management, with main focus on hydrology, hydraulics, and environmental engineering and management. Of course, you can see him. He's physically present to present his paper titled Spatial Analysis and Assessing Flood-Prone Area and Soil Erosion Vulnerability around the major influent rivers of the Lake Kivu on Rwanda site. You are welcome, sir. You have 20 minutes for the presentation.
Thank you. Thank you, the moderator. Yeah, I'm not yet a doctor, I'm an engineer. This
okay.
Is also, yeah, we have also to do this one, yeah. Thank you everyone also to come also to hear my presentation related to special analysis in assessing flood-prone areas and soil erosion vulnerability along the major tributaries of Lake Kivu on the Rwandan side. Here, I'm coming from Ines, Ruhengeri, Department of Civil Engineering, as you are saying. The outline of my presentation is first introduction, and also to talk about the objectives, material and method that has been used in order to achieve the objectives, results and discussions, and the final conclusion and the recommendations. Flood, landslide, and soil erosion are among hazards that most countries do not have capacity to estimate the magnitude of disaster they are causing. Information about losses from them is crucial to develop policies for those risk reductions. And this research aims at assessing flood-prone areas and soil erosion vulnerability around the major tributaries of the Lake Kivu on the Rwandan side. Yeah, let's come to the objective of the study is to assess the flood-prone areas and map soil erosion vulnerability of Lake Kivu basin on the Rwandan side, but the specific ones are to assess the impact of flood and the soil erosion vulnerability on socio-economic development of households in the prone areas, to analyze the intensity of vulnerability within flood and soil erosion in the affected areas, and to propose possible mitigation and preventive measures, even coping mechanisms, immediate action to withstand the event. Yeah, when we come to methods, first of all is the data correction, and we have corrected the rainfall data and the runoff data, and we use also GIS technology, and we use also remote sensing by analyzing land use and the land cover data. And after also, we use also digital elevation model. And after that, we do the modeling, hydrological modeling using HMS and the hydrodynamic modeling using HECLAS. And when you are looking to the methodology of flood mapping and analysis, we start by terrain processing in ArcHydro tools. And after we go to HMS for processing, and after we come to hydrological modeling in order to determine the peak flow or the unity hydrograph. And after having also the unity hydrograph, we have also to calibrate the model using also hydrodynamic models, HECLAS, and thereafter also using also collected data from measurement. And after that, we go to water surface profiles, and we calibrate also the model. After that, we map the flood hazard and depth estimate. For soil erosion vulnerability, we consider first the factors which are influencing soil erosion vulnerability, in which include hydrology, drainage density, land use, land cover, and slope. And also were discussed and evaluated by using satellite images, field database, and published maps. And all extracted thematic maps were classified on the basis of the importance and the characteristics for erosion sustainability, and mapped by applying weighted overlay method in ArcGIS. Yeah, with this table, we are talking how we rank or weight some thematic layers, starting from drainage density, from low to very high. Low, the weight is 1, and the very high is 9. When we come to the slope, it means that the low slope from 0 degrees to 17 degrees is 2, and we continue when we come to the high slope, the steeper slope, it is 9. And when we come also to geology, also we rank like that one. Yeah, and for land use and the land cover also, for example, if we take forest cover, we rank as 1. But when we come to barren land, we come to 9, and so forth. Yeah, let's come to result and discussions. First of all, we start by the field survey. From the historical data, even literature, we have seen that there are about 127 tributaries of Lake Kivu on both sides of Rwanda and the Congolese side. But for this one has generated a GIS software. We have also to investigate if are they true tributaries or not. And we did the survey from Kabuno at Goma. We go Minova, Karehe, Bukavu on Congolese side, and from Rusizi, Nyamasheke, Karongi to Ruwavu on Rwandan side. After that, we have found that a total of 17 major tributaries among 50 rivers on Congolese side. And after on Rwandan side, you find 9 major influence among 28 rivers. And after we were interested, especially on Rwanda side. And for those tributaries which are the major for Rwandan side are Sebeya, Pfunda, Koko, Moredi, Musogoro, Nyabahanga, Chirimbi, Karundura, and Kamiranzovu. And to classify those major, we go to what we call stream order or star order. And after we analyze also how also the discharge collected, how much it is. And after we selected those major tributaries. And when you are looking to this table, we are showing some data which has been collected by flow measurement. And after we selected those tributaries. And this is an example because we did a lot of time in order to be used in the calibration. And therefore, we found those tributaries and the discharge, we compute them in order to be used. And after using also rainfall data and the other parameters, and we have also established also water balance using the Thornwhite method in order to see if we are going to find from the model is similar to what we can find by computing manually. And after that, this one, we have found that the peak flow is of the study in the study area is found in April and in November, and the base flow where we have almost 0 drop is from May to July. Let's come to flood area in those areas. And after we start by Sebeya and Pfunda, because Pfunda is also a tributary of Sebeya. And this map shows also the flood area according to the land cover. Yeah, when you are looking to this to Pfunda River, the most affected area are irrigation and agriculture, where the irrigation represent about 56% of the flooded area, and the open agriculture about 43% of the flooded area. When we come to Sebeya River, the most affected area, according to the histogram, the most affected area is agriculture and build-up area, respectively. For Coco River, we found that the most affected area is open agriculture of about 84% of the whole area in the flooded area. And when we come up to Ruhengeri River Basin, we have found that the most affected area are open agriculture and irrigation, respectively. And when we come to Musogoro River, the most affected area are is the crossed agriculture of about 66% of the whole land cover crosses. And when we come to the Nyabahanga River Basin, we have found that the most affected area is the open agriculture, with about 97% of the whole type of land cover in the subcatchment. And when we come to the Kirimbi, the most affected area are open agriculture and respectively. And when we come to flood-prone area in Karondu, as presented on the map and the histograms and the statistics, the most area is the open agriculture. And after for Kamiranzovu, the most affected area are open agriculture and irrigation, respectively, with 40 and 48% respectively. In general, looking to Rwandan side, according to land cover classification, the most affected area are open agriculture, irrigation, and build-up areas with the percentages. When we come to the soil erosion vulnerability modeling and mapping, land use is one of the most important thematic layers which trigger the erosion to a great extent, as it includes the natural and man-made features such as water bodies, vegetation, forest cover, even barren land. And the main impact of soil erosion in this include also landslide, occur mainly due to the improper activities such as deforestation, agriculture, which lead to the overexploitation of such kind of land, even the increase in urbanization, without also forgetting also mining activities. By mapping, and the land, we have found that inlet, it means that is at the high risk zone of soil erosion. And this is in the results show that the most affected area in the soil erosion are Nyamasheke, Rusizi, and the southern part of Karongi district, respectively. And this is due to the soil types, steeper slopes, and the land cover characteristics. In conclusion, this research aims at assessing the flood-prone areas and the soil erosion vulnerability of the Lake Kivu basin on the Rwandan side. And for flood mapping, we have found that we have identified flood-prone areas in Lake Kivu tributaries of about 5,000 hectares. And most affected lands are agriculture of about 3,000 hectares, irrigation of 700 hectares, build-up area of about 400 hectares, and closed agriculture of about 250 hectares respectively. About soil erosion vulnerability, the most affected area are Nyamasheke, Rusizi, and the southern part of Karongi district, respectively, because they are almost barren lands, whereas the north part is covered by forests like Gishwati and so forth. This is due to the topography characterized by steep slopes, soil characteristics, land use, land cover types, including deforestation, overexploitation of land, agriculture, and mining activities, among others. As a recommendation, we are suggesting that a policy of riverbank protection, afforestation, and sensitization of people not to cut trees, especially along the rivers, even construction of detention ponds. Land cover restoration reduce, those will also reduce, flooding, and the land cover restoration should be able to reduce soil erosion and the landslide risks. Organized mining activities coupled with restoration should help reduce soil erosion vulnerability. In addition to above-mentioned measures, settlement relocation and anti-erosive planting are necessary. Thank you for your kind attention.
Thank you, Engineer Nahayo, for that beautiful presentation. The research is deep. So please, let's have questions for Engineer Nahayo. Questions from the audience? Hold on. I'm going to ask my HOD to ask questions because I know it's his area. Or are you working together? Okay, good. So, yes, HOD is going to ask or make suggestions. Okay.
Thank you, Deogratias, for the good presentation and research. I know the project. Just I want to suggest, like, if you are using this kind of model, like HHMS and HECLAS, it will be better if you show the result also, because they like flood hydrographs. The flood hydrograph comes from the HHMS are the input to the HECLAS model, and that peak discharge is the one that will transform to the map that you added here. So I suggest maybe this to show also for the next presentation, to show this floods hydrograph. And also, I can maybe ask one question. It was yesterday a little bit discussed here, but it's about how did you manage to use the land use, land cover data and the soil data in the models, in the like HHMS, because we found yesterday with Jean Damour, was one presenter, there was a discussion about how, for instance, because we don't have hydrological soil data in the map, but there are other methods to transform the FAO map that we have into the hydrological soil classification. To listen from you, how did you manage this? That's the question number one. And also, I would like to ask how I know it's thing to calibrate these models for when it is about the big area on the catchment level. What are the challenges in the calibration? Especially, what are the parameters that you changed in the model? Because I know we sometimes we work together in some models, and this is really challenging when it's about the calibration to have the result that we can trust. Thank you so much for your good presentation again.
Thank you, engineer. Can you respond to the questions?
Thank you, Dr. Rukundo, for your questions or your comment about the presentation of the result. I know that the unit hydrograph is one of the most important also to put in HECLAS, which is generated by HECHMS. And in the full paper, unit hydrograph is there. I summarized during the presentation. I didn't put the unit hydrograph. For the first question, you are talking about how to manage land use, land cover data in HECHMS. And this also is completed by also question number 2, which is also interconnected to challenges which can meet during the modeling and the calibration. Yeah, when we are analyzing land use, land cover, we use satellite images. And as I show you in my presentation, we use Landsat 8. And after, we proceeded to the land classifications. But when you are doing also land classification, it means that also you have also to go on the field in order to see if, for example, there is also some mistake during also analysis, during classifications. There are some stages of land classifications, and you have to analyze and to if what you have found by software are similar to what are found in using remote sensing. And when we come to challenges, we are and thereafter we have also to have also the thematic maps from historical data, and you compare them and we use them in the model. Challenges which we met during using HECHMS is in, especially for a large area, is that HECHMS is used for a subcatchment where we are analyzing one outlet, whereas here we are analyzing 9 outlets. And for this one, it means that you analyze each subcatchment. And another challenge we met is to find also the curve number, the real values of curve number. Using soil conservation services curve number method, which has been applied in the USA, but is now widely used in
behaves well with fire. It has a satisfactory performance towards loading when you load it with fire. And you see the building in the picture. It has been burnt, but you can still see it's still looking as if it can stand. And that's the way concrete behaves. But if it was steel, it will melt and become a mass in the ground. And as soon as the fire goes, it solidifies back again, so to say. Now, the key thing about fire loading is spalling. And this happens when, when cement reacts with water. you have the cementitious material, the calcium silicate hydrate. But then you have a byproduct called calcium hydroxide or portlandite. That's what we call it in industry. It is always there. It forms about 18% of the byproducts from concrete. And this calcium hydroxide, when you set it on fire, is what expands, because it will change to calcium oxide, and of course it will release some water. So it expands inside the concrete, and that's why you see pieces of the concrete falling. So the aim is to see this calcium hydroxide that is left in the matrix. How do we reduce it so that when you set that concrete on fire, yes, it will burn. Everything burns eventually. But somehow it will take a longer time, or it will take a lot more fire to make it collapse. And the other thing is that we're looking at using metakaolin, which in the next slides I will try to demonstrate. It is available and we can have it. Now, the codes of practice that are available will inform us that the cement we have is OPC, ordinary Portland cement, or SEM1. But many of us have signed an accord on climate change. There's still a conference going on now on climate change. But in 1985, certain moves were made to see how to control the amount of cement that we use. So the trick is you add things that don't need carbonation. You don't need to burn them to the cement so that you have it. For instance, there's this SEM2 that is very popular in my country. I don't know about here. But you cannot find SEM1, you cannot find OPC between Senegal and Nigeria. There's nobody making it again. So what is SEM2? SEM2 is you take the OPC, instead of a bag filled with 100% OPC, they take away up to 33% of the OPC to use for making other bags, and you add something that is inert. In our case, we use limestone. So you just grind limestone, you mix it, and you bag it. And that is what in industry is accepted. So with this, Rwanda signed in 2016, Nigeria signed also in 2016, or 2015, late 2015. You can see the map of the world. Almost everybody has signed to this accord. So if we're not attuned to it, when our buildings face fire, we'll be in trouble. Now, let's get down to some of the, you could say, the literature or the theory. As I said before, you heat concrete, and it first loses the water in it. So at around 100, 150 degrees Celsius, water gets evaporated. Any water that is left inside your concrete, there's always water there. And then after that, you see that certain aspects of the portlandite start to expand and get destroyed. By 300 degrees Celsius, all water is gone, and the hydrated products will start to, you could say, lose their strength. And usually between 350, 400 degrees Celsius, all calcium hydroxide becomes calcium oxide. Now it continues to about 800. And the graph by the side is showing, you could say, how things burn. You see, if you have a fire inside a tunnel, it's the worst case you can have. I don't think we have tunnels here. But then buildings, hydrocarbons, and so on. Anyway, in the next slide, you see that because of this, many of the design guides talk about give so much cover for 1 hour, for 2 hours. Like the story I told you before, the building burned for 4 hours until nature came to rescue with rain. And it was on a weekend, so you can imagine how much trouble it would have been to even get to that floor, to, you could say, to stop the fire. There were doors, there were things locking it up. Anyway, the next slide shows more or less a progression. And from from literature and from experimentation, normally you don't go beyond 1,000 degrees Celsius. So for this paper, we stopped at 800 because by the time you get to 800, the concrete would have reached a stage whereby if it doesn't denature in totality, it doesn't go beyond that temperature. And there's a brief summary of what I've just said. The inbound water evaporates, a little bit of cracking happens. Then after that, you have Portlandite expanding. Then after that, you start having spalling. And that's what you see when a building has burnt. Now, what are the methods we used? We looked for the kaolin sites around. In Nigeria, it's all over. There are over 6,000 sites. In every corner, there's kaolin. Even coming from Kigali to Muzanzi a few days ago, I saw kaolin by the side of the road. He was digging for something. I don't know what it was, but there was kaolin there. It's everywhere. So it's just a matter of, you could say, calcinating it, applying heat. And in this case, we applied it to about 655 degrees Celsius. We have tests that tell you exactly the temperature you should go for that kaolin to become metakaolin. To become, meta means fired, to become reactive with cement. And then also, we varied additions. We didn't replace. Because as I said, when cement reacts, what we're interested in is the calcium hydroxide. So if I have cement and I know how much calcium hydroxide I have, I can then add to it and make sure that that is what we work with. Now, with the calcium hydroxide in place, then we can then start speaking about, we did for 4 hours, because that's about the amount the codes of practices will allow you for. We tested for weight loss and compressive strength loss with the different temperatures. I'll show some results on that. The next slide shows the map of Africa, and this researcher identified 40 sites in Nigeria, and in in Rwanda here, he already found 9 sites with kaolin, but you can see the distribution around the world, around the African continent. It's available. Yes, it's not so much in North Africa, but Africa south of the Sudan, we have it. And then the next graph by the side is we carried out some tests to know which temperature is the best for us to get reactivity. So what you do is you take a bit of the kaolin you have, you fire it to different temperatures, you make a reaction, and you know which one is the best temperature for consuming calcium hydroxide. Then you can use that in the concrete. They work very fine. So the sample we're presenting here, this is the graph we did, and we were able to find 655 degrees Celsius. The next slide shows, you could say, the apparatus, which the beautiful thing about concrete is that you can make many of the equipment, you don't even need to buy it. We made this in our laboratory. The ideal one is to the left. It's a modified Chappelle's test. And on the right, we actually made 12 cells, so we can test 12 samples simultaneously. So you can fire to 400, 500, 600, 620, 670, and then test. It's a titration process, so you are able to know exactly when that, you could say when your metakaolin is good enough. Now, the next slide shows 28 days crushing strength. And as you can see, the blue is when we didn't fire it. At 200, you can see the strength jumped. So it's as if heat actually helps if it doesn't go beyond 200. We're looking at this for annealing in 3D printing, but that's a different case. We're looking at fire loading. But then as soon as you reach 400, you see it fall again. And then by 800, you've lost almost all the strength. However, you can see that the addition of metakaolin helps, because you can see the last graph is slightly rising, which means that pozzolanity helps because it has consumed the calcium hydroxide, there's nothing for the fire to attack until we get to a more terrible case. The next slide is showing addition levels and strengths generally. And as you can see, we're looking at 7, 28, and 57 days. The catch with adding supplementary cementitious material is that it doesn't kick in until after 28 days, because you must have the calcium hydroxide coming out, and then the metakaolin in the matrix, in this case, is the one that reacts with it, and you get more cement, more cementitious material. And you can see that there's a difference of almost 50%. We'll speak about that in the conclusions. The next slide is about mass loss. And in this mass loss, you see that we took the one of 57 days. We are showing that of 57 days because that is the closest to what will happen if I set a building that has been there for 5 years on fire. Though we're still looking at 250 days and almost 400 days concrete to see how it behaves with fire, because that will be closer to what we have in reality. And as you can see, we lose as much as 10%, depending on whether we have added or we haven't added. You see that really the additions show. But then what happens here is that it is now the cement itself that starts to break down. But it takes a bit longer for it to lose the mass. Now, 57 days strength.
Dr. Labino.
Yes.
You have 4 more minutes.
Okay. Vis-a-vis the crushing strength. That's what the next slide shows. What are the conclusions? The first is that we can get 50% more strength when we add metakaolin. That would make SEM2 work for us. Second is that the cylinder strength, we rated the concrete for 25. We were able to achieve 45 with the addition, which means we can save on cement in the mix. Also, we saw that 7.5% addition level was best. The other conclusion, which is in the next slide, is that, yes, we lose compressive strength progressively with fire loading, but then there's a mass range of about 0.46 to 11% as it gets worse when there's fire. And then by that time, all pore water disappears. And then pozzolanity helps in fire resistance. And lastly, the degradation might be there, but it's more drastic if there's no metakaolin. The last slide shows some further reading if we're interested. And thank you for listening.
Thank you, Dr. Labiron, for that presentation. Now is the time for questions. You know, this is the issue is, it has to do with safety, and everybody is safety conscious. So let's ask questions that will improve the work. Thank you. Okay. Okay, making 2. Okay, we have 2 questions.
Okay. Thank you, Doc, for doing justice to this topic. It was a wonderful presentation. I want further explanations on your 28 days crushing strength. That's the graph, as it varies with temperature increase. I noticed that when the temperature was at 200, you had a drastic increase in strength for up to 7.5%. Why is that increase? And of course, when it gets to 10% kaolin, the strength dropped as the temperature increased. Why is that variation? What's the chemistry behind it? Thank you.
Okay.
I think you should answer that.
Okay, I can answer. Okay, fine. What we discovered was that when you increase to 200, it seems hydration, you know that I said you wait till 57 days to see an effect. It seemed hydration got accelerated. You know, the calcium hydroxide had happened. There's metakaolin waiting to consume it. It's there. So what we're now seeing is that can we actually, you know, in some sites, they use what we call steam curing. Can we actually get some superheated steam? You can see the graph shows that the thing kicked up at 200. So that is already something that we're looking at very closely. So yes, it seems as if hydration was accelerated, and then everything, you know, instead of waiting for 57 days, was happening at 28 days. Now, the other thing is that the 10% drop is because at 10% metakaolin, you need more water to, you could say, for the mix. You know, there's more material there. So when you now fire it, the metakaolin at 10%, about 2.5% of it has not reacted. So it is waiting for something to bind with. There's nothing to bind with. You fire it, it's the weak point. So you see that drop. So it's like a validation that you should not go beyond that 7.5. After that, it's just a filler. You're wasting your time. I don't know if you understand what I mean. I hope that answers your question. Okay.
Thank you. Let's have a second question. And the last one, because we are going to the next paper, is a virtual presentation, and we don't want to delay the presenter.
Thank you, Doctor, for your presentation about the performance of the concrete on the fire. Yeah, one is not like a question, but I need clarifications. How do you link your topic with climate change?
Okay.
This is the first one. And the second one, at which concrete grade did you choose in order to test the performance of the concrete with the fire? And after, I'm seeing that you are saying at 7 days, 14 days, 28 days of age. And after, when you are looking into this one, do you take cubes of the same age and the same concrete grade and test them in order to see the performance against the fire of those cubes? Thank you.
Okay. Thank you. We did about, for this paper, we did about 600 cylinders, because the Euro codes now is asking us to do cylinders, though we've calibrated this for cube strength. We also took some cubes just to check. We rated the concrete for 25 megapascals at 28 days. But the tables you will see is calibrated for SEM 1, for OPC, where the bag is full of OPC. But most manufacturers have started replacing, because you start seeing things on the bag like SEM 2BL. It means that they've added, L means limestone, B means 33% has been taken away and limestone put in. So how does that affect climate change? It means that, number one, these replacements that the cement manufacturers are doing is saving on how much carbon dioxide they are releasing. So instead of releasing 1,000, they are now releasing 700. So the effect is a bit slower. Second, when you add metakaolin and I'm giving you 50% more strength, it means I can even use less cement to come to the same strength. So if I want to do 25, instead of we were talking about 124 yesterday, I can even give you less cement. We can use less cement because I'm using the waste material inside the hydration, but I'm going to wait for it. I don't know if you understand what I mean. So with climate change, we are not using too much cement, like the man who never put metakaolin at all. We call it clinker reduction or clinker substitution. Now, the other thing about climate is that if you get a stronger concrete, then the time for that concrete to serve you will be longer. So for instance, I didn't mention it, but with weight loss, I can go to a building that has burnt. I take a sample, I take a core, I check the density. If it doesn't fall below the density of 2,400 kilograms per cubic that normal weight cement should be, because of my metakaolin, I can then just chip it off, replaster, and continue, because I have data that tells me that this is the strength that I have. If I like to borrow from the remanufacturer, I don't need to break the building, because I have data that tells me that if my density, my weight loss has not dropped, I'm good to go. So in that sense, I don't waste cement repairing something that I have data that tells me that it can serve. I don't know if you understand what I mean. So with climate, I'm winning in all directions. Okay? Thank you.
Okay, thank you. We have just 2 minutes before the next presenter, who is presenting virtually. So let's quickly take, within the 2 minutes, your question and response. Thank you.
Okay, thank you, John, for your presentation. Me, I would like to know if this task done was the new, or if there are other authors that have done on the same topic. If yes, what was the similarities in the result? And what do you recommend or advise other countries apart from Nigeria? Because I'm seeing that the case study was based on the Nigerian clays. Thank you.
Thank you.
Quickly.
I like that question. Yes, metakaolin was discovered in Brazil in 1952. But you see, the kaolin in Muzanz is different from the kaolin in Ibadan. In fact, the kaolin I'm using, I went to look for the most beautiful, the sweetest kaolin in Nigeria. So I had to go to a part of Nigeria which has very good food. So I had good food, but I got kaolin. And the kaolin there was so good that I could record 2,400 with 1 gram of the kaolin. I can consume 2,400, or 2.4 grams of calcium hydroxide with my test. So what is new is that everywhere you see kaolin, there will be differences you can characterize. So it's not just about kaolin from my country. I can come to Muzanz, I can go to Lake Kivu. If I find kaolin there, I can tell you what it will do for us. Second is that, can other countries have it? Yes. From that picture of Africa, I don't know this country very well, but somebody has located 9 places you can find kaolin. And thirdly, you see, when I found kaolin, I realized that people treat it like waste. They're interested, it comes with fletspar, which you use for electrical conductors. You know these conductors for high tension.
Dr. Labro,
yes,
I have to stop you.
Okay, sorry.
Just conclude that statement.
So, the kaolin is available. It's a waste. So what is new is that whatever you are doing, you can characterize it for what's happening in your place, in your area, in your state. Okay?
Thank you very much. Thank you. Our next presenter is Arowolo Samuel Boyega. Is he online? Okay. Arowolo Boyega. So he's presenting, his paper is on mechanical properties of normal concrete, incorporating rice husk ash, waste ceramic tiles, and broom fibers. He is of the Department of Civil Engineering, University of Ilorin. Engineer Boyega, You are welcome.
Thank you, ma. Okay. Good morning, the moderator, the chairman of the organizing conference committee, and every participant in this awesome international conference on civil engineering education, Rwanda 2021. I'm here this morning to present a paper titled Mechanical Properties of Normal Concrete, Incorporating Rice or Ash, with ceramic tiles and broom fibers. And my name, as rightly mentioned, remains Samuel Guega from the Department of Civil Engineering, University of Ilorin, Nigeria. And in a couple of minutes, I'll be speaking briefly through these contents as outlined here: the introduction, literature review, materials and methods, result and discussion, conclusion and recommendation, and then some few references. I'd like to start this way by saying that concrete plays an important role in the construction sector. The growth in demand of high-rise buildings has led to upsurge in the quest for better performing concrete materials and its composite. This research mainly focuses on how to improve the sustainability of concrete and waste management by using locally available materials. Many modifications and developments have been made to place agricultural byproducts or industrial waste, such as waste ceramic tiles, rice husk ash, and locally available contents as supplements or addition to the conventional constituent of concrete. We all know that concrete is weak in tension, and cracks are developed very easily, and that may propagate and finally leads to the breaking of concrete structure. In order to cater for these, fibers, which are, in this case, I'm using natural fiber or oil palm broom fibers, will be incorporated or was incorporated to enhance the flexural strength of the produced concrete. In summary, the aim of this research is to compose constituent materials for normal concretes with high performance indices of mechanical properties using suitable local alternative materials. Therefore, in order to achieve this, the mechanical properties of normal concrete, including its density, compressive and flexural strength, were determined to know the suitability and how essential this could be for different applications. The literature review were focused on the mixed proportion from similar researches, and I'll just talk briefly on some of them because of so much I have on my slide presentation. The first author there, Willie et al., 2011, and Pyle Kim, consider two aggregate size ranging from 0.2 to 0.8 mm, and then the produced concrete was cured in 20 degrees Celsius temperature, and so many constituents were fibers, super plasticizer in order to aid the flowability of the produced concrete, the aggregates greater than 1 mm and also less than 1 mm, limestone, metal kaolin, glass powder, silica flour, fly ash, GGBFS, ground granulated blast furnace slag, silica from water and cement. Just a brief overview of the various mixed proportions that have been employed by different researchers based on the scope of this work. And I would like to go further. The materials composition of the normal concrete produced include cement, ordinary Portland cement of grade 42.5, aggregates, carefully selected using sharp sand of grain size 0.1 to 1 mm, granite chippings between the range of 5 to 9 mm, and then super plasticizer, rice coarse ash with ceramic tiles and oil palm root fibers are shown in the next slide. There are pictures, so you can see. And the rest of them, and the super plasticizer was ASEAN tooth crates, like I said earlier on, in order to enhance the fluidity of the produced concretes due to the addition of fibers. Materials and methodologies. Response surveys is a popular research tool in the field of design of experiments that helps in refinement and optimization of response. Similar method was also used for various purposes in past studies. In this experiment, the use of procedures established by therefore, 8 different concrete mixes were designed as indicated in table 2. The next slide to be shown from which concrete specimens for mechanical properties were investigated, was examined for its physical properties as shown in table 3. Then the RHA, which is rice coarse ash, and WCT, with ceramic tiles in powder form, were tested for their physical and chemical properties, as also presented in table 4. So I use this mixed proportion as established by similar researches for Taguchi orthogonal by engaging design of experiments. And these are the pictures of the various stages of mixing, casting, and curing of produced concrete. Just a sample of them, not all anyway, because they are done in batches. And result and discussion. The geometry and physical properties of short, discrete, random fibers were added to the concrete mix as shown in table 3. As we have the mean diameter in micrometer of 220, the mean length also in 13.0, and the aspect ratio of 59, the density 1.1. The oxide composition of WCT and RHA in order to establish their pozzolanic characteristics as presented in table 4. Table 4 speak more of the various oxide composition as we have it in ceramic tiles and rice coarse ash. Considering pozzolanic nature of ceramic tiles and rice coarse ash, we can see that the silica oxide there in ceramic tiles 69.69, the iron oxide 7.19, the aluminum oxide 2.67, and rice coarse ash, which is a very well-known pozzolanic material too, is having 90.21 silica, or let me say silicon oxide, and the iron oxide of 0.93 and aluminum oxide of 0.18. Other compounds too are also important, but these are just the main parameters that are generally being considered when referring to pozzolanic nature of any cement supplement. Okay, and I would like to also give a brief overview of the mechanical properties of the concrete that was produced based on those mixed proportions. We have mix 1, 2, 3, 4, 5, 6, 7, and 8. And on this table 5, there are some of these values are giving promising. Some of these values are worth noting, like in mix 1, the lowest at 7-day compressive strength is 8.40, and mix 6 at 7-day curing age is having 12.74, and the rest like that. Like I have a chart in the following page to illustrate this further. The produced concrete specimens were investigated for fresh and hardening density, compressive and flexural strength as presented hereafter. So on this chart, we have the fresh density being plotted against the different mixes that was developed. And we can see that at the base level here, we have mix 1 having 1877 kilogram per meter cube, and then mix 3 having as high as 2036 kilogram per meter cube, which means that there is not really much loss in weight due to the addition of those constituents. Then on this chart, we have that was for the fresh density of the concrete. This is for the hardening density. We also have these values. Then talking about the compressive strength, it's obvious that the compressive strength of all the mixes increase with curing age, showing the most promising compressive strength in this order of 34.60 Newton per millimeter square and 33.8, followed by 33.1, while the corresponding mixes are mix 6, mix 5, and mix 7 respectively at 28 days curing age, as revealed in the figure 8 beside. Then I would also like to talk briefly about the flexural strength that has been plotted against the mixes only at age 28. So based on similar researches, using a straight short discrete broom fibers with a diameter of 0.2 mm average diameter and a length of 13.0 mm led to a promising flexural performance with notable value of 8.67 Newton per millimeter square by mix 6. So mix 6 is giving us a much promising result than the rest, both in compressive and the flexural strength. I would like to conclude this way by saying that the aim of this research, as rightly stated, is to compose constituent materials for normal concrete with high performance indices of mechanical properties using suitable local alternative materials. I would like to quickly run through that the effect of RHA and WCT on concrete mixes is mainly due to their pozzolanic behaviors. Addition of both RHA and WCT affects the mechanical properties of the produced concrete. Then the compressive strength of all the mixes increases with curing age, showing the most promising compressive strength in this order of 34.60 Newton per millimeter square, and the rest of the value, while the corresponding mixes are rightly stated here at 28 days curing age. The oil palm broom fibers influence the flexural strength of concrete with mixes notable value as high as 8.67 Newton per millimeter square by mix 6 at 28 days. So I would like to say that for further studies, it is recommended to investigate other concrete properties in order to have adequate information about the suitability of the developed concrete, and as well to know its cost effectiveness. And I have all these limited references to support this presentation. Thank you all for listening.
Thank you, Engineer Boegarolo, for that presentation. Now is the time for questions. so that we can help to improve the work. Yes, it's only one hand. 2. On this side. Okay, 3. And that ends it. So let's start with Dr. Tapu. Please, let's make the questions and responses snappy, because we are going to have a virtual presenter again from a keynote address from UK, and we don't want to delay.
Thank you for a good presentation. My worry is that you are using 2 pozzolanic materials with similar properties in concrete. Does that not amount to cooking rice and yam? Because the 2 of them are doing the same work. You didn't check the amount of lime that is released from your cement hydration to have concluded that perhaps using rice husk ash alone will not consume all the lime, and so you need to bring another similar pozzolana to now take up the remaining lime. Why do you choose to use rice husk ash and crushed ceramic waste when the 2 of them are doing the same type of work in your concrete?
Can I answer that?
Please respond.
Okay. Considering the addition of fibers, definitely reduce the strength gain, the compressive strength, which we know is a very important parameter in concrete. That's why I needed to use those 2 pozzolanic materials in order to supplement for the strength development. That's the main reason. Any other reason is immaterial.
Hello, can I also contribute to that because I co-author the paper?
Okay, please go ahead. Tell us your name.
All right. Okay, my name is Damlola Oyejobi. I'm also part of the authors of the paper we were presented. In addition, we also make use of the 2 pozzolanic material because the resource serve as a filler, while the waste ceramic tiles also serve as main pozzolanic material. So to fill up the void, because from the misproportion that we calculated, we actually want to ensure the well-packed density. So the rice husk can fill up the void, while the waste ceramic tiles also now serve as the main pozzolanic material. Thank you.
Thank you.
Still on the issue, we carried out in our own laboratory the amount of calcium hydroxide that each of the pozzolan that you are proposing can take. And waste ceramic is less because it's dependent on the different kinds of tiles you find. Definitely the glazing on the tile for some of those tiles is not pozzolanic. So in that sense, it seems you are using something as a filler when it is more reactive than the other one, which is not as reactive. I think you should look at it. Second, what is the particle size of your waste tile when you grinded it, and of your rice husk, because it also matters. If it's too big, that's I'm talking about, if the particle size is not right, it will not react. Then my own question, in addition, is that I guess you are aware of the bamboo debate. Everybody is talking about bamboo as reinforcement. And my own opinion as a researcher, it's a dead end. But anyway, let's take it away from there. The broom fiber you are using, I think you just, again, you grinded it or what? What is the size of the broom fiber you are using? Because I guess you are using it as a fiber. What is the size? And how do you guarantee, say, in 3 or 4 years, that that wood will not rot or denature? Because concrete is not, the environment of concrete is not, how will I put it, airtight and watertight, so to say. So, and once water touches something that is organic, that is a plant fiber, you have to be careful as to whether it's going to rot. Can you answer that for us, please? Thank you.
Okay, sir. Thank you, sir. For the average grain size for waste ceramic tiles and rice coarse ash were as low as 600 micrometer. Though to process the material was challenging, but I ensured that I was able to achieve that. And then for the length of the broom fiber was 13.0 mm. It was also stated in one of the tables there during the presentation. And then considering the durability of this produced concrete over time, like I said earlier on, that this is still an ongoing research. That aspect will also be considered over time.
Much. The last question from the gentleman here.
Thank you for your good presentation. But in your presentation, you tell us the result from laboratory. But you didn't tell us the concrete mixing ratio. If you have it, you can tell me the concrete mixing ratio in order to understand very well your performance in your research. Thank you.
Okay. Like I stated earlier on that I use a response service method, engaging the procedures established by Taguchi orthogonal axis. In that case, the mixed proportion were developed from the various researches as established in the table 1 there. So I was only able to get those values, but I didn't add the mix ratio, as you said, maybe one ratio, so and so to the table, but I can obtain it directly.
Thank you, Engineer Boyegarolo, for your presentation and for being supported by your co-author. I think we can disengage you now to go and do other things. Thank you very much. She's going to present physically because she's been here since Monday. And she's Engineer Temitope Ayodele. Engineer Temitope Ayodele. She is a technologist in the Department of Civil Engineering, University of Ibadan. Our research interests are mainly in the area of geotechnical and highway engineering. Of course, she's here to present a paper which is entitled Geotechnical Basis for Pavement Failure Along Akure-Ado-Ekiti Road, Southwestern Nigeria. Engineer Ayodele, you have 20 minutes. Thank you.
Thank you. I'm here this morning to have a presentation on the technical basis for road pavement failure along Akure-Ado-Ekiti Road. Good morning, everybody. Muraho, Rwanda. Yes. Okay. Yeah, I have my presentation outline, the introduction, the aim of and objectives of the research, the methodology, results, and discussion, and the conclusion. Roads is a major facility in determining the level of development of a nation. In fact, it's a major yardstick that is being used to know the level of civilization. And of all the means of transportation, road is the cheapest, though with highest risk of accidents. Apart from the fact that road is used to measure yardstick in civilization, it's also a means of comfort. If you are applying on a good road, you are more comfortable, it reduces your travel time, and of course, you are more comfortable. Yes, it increases your comfort as a user. And I will talk about malfunction of roads. Malfunction of roads, we talk of poor roads, it induces paralysis to the economy of a nation. If you are working on a poor road, your travel time is increased, you are more discomfort, and all your activities will be paralyzed. Besides, you spend more time, you spend more money on your car maintenance. You see that you visit your mechanic often to check for one fault on the other as a result of tears and wear on your automobiles. Then the scope of this research is on a flexible pavement, and the pavement section may be defined as a structural material that is contained of series of layers placed on a subgrade that is also known as the foundation of the road. And of course, it has 3 layers. You have the surfacing, which is at the top. You have the base course, you have the subbase, and you have the subgrade. The subgrade, like I mentioned earlier, serves as the foundation, or you can also call it the formation level. So the principal function of the subgrade is to receive load from the traffic through the various layers and transmit the received load to the surrounding soils. And there are various defects in flexible pavements. Of course, there are 2 types of pavements. You have the rigid pavements, which major constituents are concrete, and you have the flexible pavements, which major constituents are the structural layers and the surfacing, that is the asphaltic surfacing. Now, there are various types of defects in flexible pavements. You have cracks. You have cracks, and you have deformation, defect as a result of deformation. Now, the cracks occur as a result of partial or complete fixtures on the surfacing. Once crack occurs, what happens is potholes. You begin to experience potholes, and it leads to other types of failure. Wow. IT, can you help me take it to slide number 6? Okay, yes. And I've got types of cracks. Cracks normally, they don't alter the movement on the road. You move on smoothly. You might not even notice any failure. So you have crocodile cracks, you have block cracks as shown on the screen, you have edge cracks. Some of these cracks are caused, like I said earlier, according to fixture. When there are openings on the surfaces, you begin to experience cracks. And sometimes they are caused by loss of bonds between the asphaltic surface and the underlying layer, especially the base course. And they are also caused based on low thickness of the asphalt. Now, the next slide will show us, okay, this is showing me various types of surface deformation. Well, a surface is deformed when the original profile of the road is changed. Like I mentioned earlier, when you have cracks, you can actually move smoothly without noticing failure, but surface deformation, you begin to notice some failure, and it is manifested in form of shoving. Shoving is also called eaving, and this eaving is caused by of course, it's still caused as a result of loss of bond between your base course and your surfacing. It's also caused by excessive loading. Then you have rotting, you have depression, you have corrugation. Depression is caused by settlement of the subgrade. It's also caused sometimes due to volumetric changes of the subgrade or the underlying base course. The next slide is showing us some of the fixtures we have on the Akure Ado Ekiti Road. Sorry, I forgot to mention, Akure Ado Ekiti Road is, okay, I think it should be on the next slide. These are some of the defects. On the plate 1, you will see cracks. The plate 1, there are various types of cracks. You have longitudinal cracks. The plate 2 is showing us heaving. Then plate 3 and 4, you have cracks that are resulted into potholes and even drum hole in the 4th plate. So the next slide is also showing us various types of defects on the road. And these defects is caused by various reasons. Yes, we're mentioning defects. Apart from the fact that the defects are caused by before construction. If I tell you that loss of bond between asphalt and subbase, they are prior to construction. Now, after the construction, post-construction causes of pavement defect, you have increased vehicular loading. Most of the roads we apply in Nigeria, I don't know of Rwanda, of course, should be applicable. The vehicular loading placed on them are not what they are designed for. You can design your load, an interstate load, truncate load, probably for 2 axles, 4 tires, passengers' cars, in some cases 3 axles, but you find out that 4 axles are applying this road. Big giant trailers carrying heavy loads are applying this road. This increased vehicular load actually leads to failure of the pavement or defect of the pavement. Now, inadequacies in design and poor workmanship. In the southwestern part of Nigeria where I come from, I worked in a consultancy before I joined the service of the University of Ibadan. And what we were doing in the firm is that, okay, once you construct a road, we will design that your base course, make it 150 mm compacted, your sub-base, make it 150 mm compacted. So total of your sub-base and base course will give you 300 mm compacted, not considering the loads that are meant to come upon these structures, not considering the number of traffic, not considering the soil properties like CBR. So the first thing you do, even for adequate pavement design, you consider so many factors. You consider the soil properties, you consider traffic, you do extensive and comprehensive traffic count to know the number and type of vehicles that will ply this road. And of course, poor workmanship. Poor workmanship is another main factor that causes defects in pavements. Then poor soil properties like low CBR, I've explained that earlier, high water table. Now, proximity of water table to the subgrade weakens the subgrade. Of course, when we do road construction, one major factor we do is that we ensure that drainage, the road is well drainaged. We provide adequate drainages on the structures, on the roads to prevent defect. So when the water is so close to the subgrade, it causes pavement defects. Then poor road drainages, yes. During road construction, you ensure that adequate drainages are provided along the road, being line drain, trapezoidal draining. Then you ensure that you have adequate coverts, cross covert, access covert, and of course, you ensure that the road is well cambered. That is, you give your pavement surface adequate slope. In Nigeria, the recommended slope for carriageway, I think, is 2.5%, and for shoulders, you have 5%. So it is necessary to put these factors into consideration. The negligence of road maintenance, this is on the part of government and individual. Yeah, governments, sometimes they wait until a road gets to a point where they can no longer be in use before they intervene. On the part of individual, illegal and unauthorized dumping of refuse along the drainages, they cause serious problems. The drainages are blocked, and of course, flooding occurs on top of the pavement, causing pavement deterioration. So this research, we look into factors, the technical parameters as factors of pavement failure along Akure Ado Ekiti Road. And the objectives are to determine the type of distresses found on the selected sections of the road, to obtain soil samples on major failed segments for analysis, and to profile solutions to incessant failure distresses along the road. Now, the study area. The area is located in the southwestern part of Nigeria, And the road is about 49.5 kilometers. It connects two major states. It connects Ekiti State and Ondo State. Akure is in Ondo State and is the capital city of Ondo State, while Ado Ekiti is in Ekiti State and is the capital city of Ekiti State. The road is classified as Trunk A road, and it connects those two major states. Geologically, the area is underlain by basement complex rocks of Nigeria. It is made up of migmatites, gneiss, and banded gneiss, medium quartz grain, beltite granites, and of course, shannokite. So this is the map of the study area. You can see Ondo State and Ekiti State, and the road, that red line, is actually the main road I'm talking about. It connects the two major cities. Now, research methodology. So to achieve the aim of this research, three methodologies were employed. The first one is the inventories and road condition survey, where we transverse the road meticulously from the Akure end to Ado Ekiti end. And the aim of this process was to actually determine the type of distresses that are found on the road. We classified the distresses and the frequency. For example, potholes. Okay, they are found also chainages. What's the number of potholes? Then if it's even, okay, I encounter even on the road. How many types of even do I have and what extent? From one chainage to one chainage. For example, it can be from chainage 2 plus 0, 0, 0 to 2 plus 0, 75, that is 75 meters. So those were carefully done and recorded. Then soil sampling as subgrade, subbase, and base course. Soil samples were obtained at 10 major field segments along the road, yes, at the subgrade level. And we also obtained 5 soil samples from the 10 for base course, at the base course level and subbase. In other words, we tested some samples below 300 mm. We took that as a subgrade. I analyzed some within 0 to 150 mm for our base course and 150 mm to 300 mm as our subbase. Of course, geotechnical analysis, we carried out some geotechnical tests like natural moisture content, atterbag limit test, grain size, for all the two mentioned are for classification tests. Then we did compaction tests to obtain our optimum moisture content and maximum dry density. And of course, the California bearing ratio. Results and discussion. The table 1 on the screen shows us the results of our road condition survey. You can see that there are various distresses evidenced by loss of asphalt. There are 16, wavy or even surface, which I termed in my earlier explanation as corrugation. We have 12. Then we have pitting or minor dents, longitudinal cracks running parallel to the center line of the highway, that is 47. Shear or massive failure of pothole extending to the subgrade, that is 24. And of course, isolated potholes, 68. It is worthy to note that when we are taking the parameter, is sometimes can be at a stretch. If you see the first one that is 16, it's not that it can be a stretch of several meters along the road. Then the next slide is the results of the subgrade testing that we did here. We took 10 samples, then at various chainages. And we did a classification test, like I mentioned earlier, we did a atterbag limit test. The aim was to determine liquid limits, plastic limits, and the PI for our classification. Of course, we did grain size analysis. So the result of the liquid limit shows that it varied from 22.2% to 37%, and our PI is from 8.8% to 11.3%. For the subgrade, it shows that the samples obtained at the subgrade layer are of low to medium plasticity. And for the MDD and the OMC, the MDD that was obtained from the compaction test, we have the minimum value of 1,800 kilograms per cubic meters to 2,510 kilograms per cubic meters. This is also shows that the road is stable, the values are quite okay. And the CBR, we had a soaked CBR for the subgrade. We soaked the sample for 96 hours in the laboratory before subjecting into testing. And we had the minimum value of 9 and the maximum value of 27%. So the values obtained, they are actually in that range. And we ended up classifying the soil according to AASHTO. Sorry, previous slide. According to AASHTO classification, so they fall into the category of A2, A23 to A27. Some of them actually had very, very good results, like A23, A24, A24, excellent materials. AASHTO classified those materials, A23, A24, as excellent materials to be used as subgrade because they are quite granular in nature due to their low plasticity. Then the next table, the next slide is showing us results for the base and sub-base. Similarly, we also carried out bag limit tests and the sieve analysis for classification. We also did compaction where we had our MDD and OMC, and of course our CBR value. In this time around, we soak the base course. Yes, we soaked the base course. Sorry, we did not soak the base course, sorry. We only soaked the subgrade, we did not soak the base course, but the sub-base was soaked for 24 hours. That is one. So from the results of the base, the liquid limit vary from 40 to 50, which shows the medium to high plasticity, and also the PI, they're from 11 to 18%, while the MDD is from 1,560 kilogram per cubic meters to 1,750 kilogram per cubic meters, which shows that this material, they are weak because the results obtained for MDD did not meet the specification for AASHTO classification. AASHTO specify about 1,900 to 2,000 and above kilogram per cubic meters. And of course, the CBR value, the minimum value should be 80% for road base. A material who does not meet these requirements is not suitable to be used as base. So the result shows that the CBR value gotten was from 50% to 63%, which do not meet the standard. And of course, the results of the AASHTO class for classification, we have A5 to A7. And for the sub-base, similarly, the material for liquid limits, they are also of medium to high plasticity, and the MDD values too ranges from 1,510 kilogram per cubic meters to 1,700 kilogram per cubic meters. It also showed that the sub-base is weak, though the materials were soaked for 24 hours. None of the base CBR values met the AASHTO standard. AASHTO specified 30% for base. A material to be used for base should be up to 30% and should be soaked for 24 hours. So similarly, it is also classified as A7. Conclusion. From the geotechnical investigation carried out along the Akure-Ado Road, the following are induced. Major distress evidence of the road are potholes extending through the pavements to the subgrade. Then the subgrade materials, like I mentioned, they are of low plasticity, they are of low consistency, and they are stable, and they are satisfying, that is, they meet satisfying geotechnical properties. The materials for the sub-base and the base layers of the road are of medium to high plasticity, and they exhibit very low CBR. Not only that, they exhibit very low maximum dry density, and they do not meet AASHTO standard for road base. Yes. Ladies and gentlemen, I want to conclude here that the quality of the base and sub-base is a major contributing factors in the failure of Akure-Ado Ekiti Road. Thank you very much for listening.
Thank you, Engineer Ayodele. From your screen, I could see many hands raised up. Will you be able to to address all the questions from those hands?
I will try.
Okay, we have, I've seen, no, I want to start from my left. Please, if you have questions for Engineer Ayodele, get them prepared.
Thank you for your good presentation. Yeah, I want to ask what type of samples did you use for the CBR? And why did you need to soak the samples for 4 hours?
So if I get your question right, that what type of samples do I use for CBR?
Yeah, the ones you used. Yeah.
Sir?
Yes.
Okay. Well, you can use any type of granular materials for CBR, provided it meets the required standard. Because if you use a clayey material, of course it is expansive, it will give you a low value. But granular materials will give you a higher maximum dry density, which will give you a higher value in the CBR value. Normally, granular materials are recommended for use for CBR.
I mean the sample types. Did you use remolded samples?
Oh, yes.
or
No,
did
yes.
you
We use the stop samples, sorry. We use the stop samples. And we recompacted in the laboratory, so it was a test that was done in the lab.
And why did you need to soak them?
Why did we?
Need to soak for 4 hours.
For subgrade.
Yeah.
Yes, sir. We soak for subgrade because we assume the subgrade can be within the water table. We design for the worst condition. So when you soak the subgrade, you assume, okay, let us assume that on the site, your water table rises to the level of subgrade. What happens? That is why we soak, to have the worst condition on site.
Thank you. Okay, Dr. Taku.
Thank you for a wonderful presentation. I passed that road recently, so I have an idea of what you're talking about, even though I was concerned more about my safety than the state of the road. I know that materials degrade with time. And so my materials that could have made design specifications today may not meet again in 20 years' time, or it may degrade within that period. Did you find out the design life of that road so that we are sure that we are not measuring, checking the properties of a road that has already lived its design lifespan? That's one. And then secondly, did you carry out any in situ based tests to see if it were possible that, for instance, the compaction that was done during construction might not have been enough from that time? Thank you.
Okay, thank you very much. Yeah, the design life of the pavement was 30 years. It was 30 years, really. And the road has not reached its design life before it begins to manifest various types of failure. So concerning the incident, I did not carry out incidency tests. I carried out the compaction test in the laboratory. We didn't carry out incidency tests, since it's a research work that was just to propose measures to just find out the geotechnical basis for failure. I didn't mean to go for construction to construct that road. I would have considered the incidency test. Thank you.
Do you have more questions for her? Okay. That will be the last question, since
Thank you for good presentation. In causes of pavement failure, we talk about increased vehicular roads. And in causes of pavement defects, we talk about increased vehicular roads. And I didn't see recommendation where you recommend they should consider in designing the roads. And the second question is negligence of road maintenance. As engineer, what could you do so that they could take care of the road maintenance? And you talk about design. As engineer, what could you do that they
should make a good design for to increase pavement life period. Thank you.
So I didn't get your last question. Increase what?
Lifespan of the pavement.
Okay. Okay, thank you. So the first question, you were talking about increased load. Actually, it is off my scope. Traffic count, traffic analysis is not, was not considered in this research. Like I told you, it was a purely geotechnical basis for failure. I just mentioned that to explain various causes of pavement distress. So I didn't go into traffic analysis. It is actually off the scope of the work. Then the next question, you said, how do we ensure that the people have good maintenance culture, road maintenance? Okay. Now, the first thing is awareness. Government knows what to do. Let us leave government parts. They know what to do. They know they are to carry out routine maintenance on these roads. Now, let's come to our level as individuals. We will carry out awareness where people continue to know the dangers that are involved in dumping of refuse along the channels, or even sometimes, in most cases, some of these maintenance are actually simple things. Okay, for example, a road that is silted by sands. What does it take us? Take spade, pack the sands off the road. But we will leave everything there for government. We will be passing the road. We will be entering the bumps that have been induced by the accumulated sand. This is our culture. It doesn't take anything, it doesn't remove any for more. We can gather ourselves together, remove the sands, and enjoy the road. Then your last question, you asked about how do I ensure good design as engineer. Of course, there are various standards for road designs. What you have for rigid pavements is different from what you have for flexible pavements. We go to school, we know the various procedures. So it is our job as engineers to dictate or advise government to ensure that standards are followed during the road design. We all know what it takes, both for geometrical design and structural designs of roads. So we should do the normal thing. We should tell government the standard. We should not mind cost. We should not construct at the detriment of quality. Thank you. I hope I've been able to answer your question.
Yeah, thank you, Engineer Yodele, for your presentation. I think you can go and have your seats now. This is 12:09. We are supposed to go for lunch from 12:45, but we are going to delay it because a presenter from UK, actually one of our keynote speakers, will come in at 12:45. So it's like we have about, let me see, we still have 30, well, let's say 30 minutes. So I think you can take a presenter quickly, another presenter quickly for that. So it's, I think the only person you can take is somebody who is around physically, because the other presenters, we have it virtually and we don't want to alter his plan. Okay, we have two presenters that will make virtual presentations. So let's go to the only physical presenter that we have. Engineer Agenda, you are trying to save time. So everything, your questions, presentation will have to be within 30 minutes because the UK presenter or keynote speaker is coming on by 12:45, and by my own time, this is 12:10. So we have, let's say, roughly 30 minutes for you. So we ask you to present within 15 minutes. Is that okay? Okay. He's from the Catholic University, and Catholic University is one of our partners in this project. So he's representing the whole of Cameroon. So please make your presentation.
Good morning, everyone. I'm Teshonkong Agendia. I'm a researcher, and I'm from the Catholic University of Cameroon, as she said. Today I'll be presenting some of my research findings in this topic coined Countermeasures Against Liquefaction Damage of Embankment, considering air bubble injection through numerical analysis. The presentation outline will follow a background literature review, and then we'll explain how I came about this research with a finite element formulation and the numerical methods that I used. And then I'll explain how the one element simulation was done, and then I'll move forward to the dynamic analysis of the embankment, and I'll give the conclusions and recommendations. We all know that the process by which an embankment can fail by liquefaction is that, first of all, the soil above the groundwater level gets saturated, and then when earthquake occurs or maybe any other cyclic loading, the effective stress of the soil is reduced essentially to zero, and then there is a buildup of excess pore water pressure, and when liquefaction occurs, the liquefied layer spreads laterally, causing a collapse or the settlement of the crest, or the embankment either fails by landsliding on one side or the crest settlement. And then when these damage patterns happen, it is important for us to establish some countermeasures to mitigate this damage caused by soil liquefaction. So here is an example of a road embankment that was damaged in Peru in the Pan American Highway in 2007. And the commonly practiced countermeasures for liquefaction damage of embankment are usually sheet pile enclosure, dynamic compaction, deep ground mixing, and now air bubble injection, which is the developing technique which we are currently using. This research, I will reiterate that it is solely based on numerical analysis. So it is a pre-disaster study to see how we can utilize numerical methods to solve the problem of soil liquefaction when a damage happened to an embankment caused by earthquake. So some previous studies have first of all been carried out in this particular subject matter by Professor Okamura in Ehime University. He started first of all by investigating the effect of pore fluid compressibility on liquefaction resistance of partially saturated sand. And in 2017, he conducted speed logging and investigation of long-term change of saturation by air injection. And his findings were that he found out that the effectiveness of air bubble injection as a countermeasure for liquefaction was quite effective. But what was not clear in his findings and studies were that the appropriate surface area for the implementation of that air bubble injection was not yet determined, and also the optimal degree of saturation was not, he didn't ascertain the optimal degree of saturation to use when carrying out this particular measure. So this research will utilize numerical solutions to clarify these points which are unclear by the use of the liquefaction computer program called LICA 2D17, which was developed by some professors in Kyoto University. So the research flow will follow an identification and a review of embankment failure caused by soil liquefaction, which we saw in the previous slide. And then I will explain the one element simulation and the reproduction of liquefaction strength curve, which is a parametric study of the various materials used. And then I will explain how the dynamic analysis of the embankment by desaturation was done. And I will also explain the dynamic analysis of the embankment in the determination of the optimal surface area, and I will do a settlement comparison of the results using different earthquake motions, principally the earthquake motions of the Kobe 1995 earthquake and the Tohoku 2011 earthquakes. And then the final goal of the research is to propose appropriate parameters, surface area, and optimal degree of saturation for the effective implementation of air bubble injection as a countermeasure for liquefaction damage. So the desaturation concept here we are using is, we first of all know that by changing the bulk modulus of air-water mixture, the effects of pore fluid compressibility can influence the degree of saturation. So the conceptual representation of air-water mixture by volume ratio was done by Okamura and Soga in 2016, where they gave a formulation relationship between the bulk modulus for the fluid, that's the air-water mixture, and the degree of saturation. So we know that from Boyle's law, the bulk modulus for air is equal to the absolute pore pressure. So if we give a derivative of that, we will have a simplified formula that has a relationship between the bulk modulus for the fluid and the degree of saturation, which we are going to use as our main input parameters for the numerical calculations. So, but before we run the numerical simulation and explanation of the model that we are using, we are first of all going to carry out one element simulation to test the reproduction of some mechanical laboratory tests that may have been done in the laboratory, like triaxial and hollow cylindrical tests. And in general, the reproduction of a liquefaction strength curve is the main target of this one element simulation we are doing. So the materials that we used are Akita sand, Edosaki sand, and Toyora sand. And we have the finite element there, which are fixed at the bottom, and the variation of the force direction is at the top. So if you look at the table below, you see that we varied the shear forces that are applied to the finite element, and then we also had a change in the degree of saturations by 85%, 95.5%, 99.9%, and 100% degree of saturation. And then the elastoplastic model for sand was applied, in this case using the same computer program Likert 2D17. Now, when we look at the liquefaction strength curves that were produced in this one element simulation, we realize that there is a consistency in one of the materials that were used, that's Akita sand, that shows an increase in the liquefaction strength when we decrease the degree of saturation. And I had the opportunity to meet one researcher as well in Tokyo 2018, that he was also carrying out these liquefaction strength curves to determine the liquefaction strength of bauxite and iron ore fiber. That's J-Lot. I met him personally, and he in this case, he used the physical experimentation. So he did triaxial test and hollow cylindrical test to come out to show his investigation showed that the liquefaction strength increased when he decreased the degree of saturation. Well, in the other two materials that I used, that's Edosaki sand and Toyora sand, there was a strange behavior which I witnessed, and it didn't show some consistency in the liquefaction strength curves. But now, after we have done one element simulation, it is important that we apply. After we have done one element simulation, we now know that from the conclusion of one element simulation, there is an increase in liquefaction strength when we decrease the degree of saturation. So now what we are going to do is that I prepared an embankment model using, I prepared the embankment model. This is a numerical model, and we have the soil profile, which is stratified into 4 layers as seen on the figure. And I use the input, I use 2 input wave motions to do the dynamic analysis. That's the input wave motion of Kobe 1995 earthquake and the Tohoku 2011 earthquake. So the 2 input earthquake motions were used, and a cyclic elastoplastic constitutive model, and an elastoviscoplastic model was applied to the Akita sand that I previously tested with the one element simulation. And then I used Lika 2D17 in carrying out the dynamic analysis. Now, for the simulated cases, we have one case, the model case without the improvement, and the other model case with the improved area. When you look at the area in green, that is the desaturated area that we have varied and reduced the degree of saturation for the soil-water mixture. So an arbitrary surface area is chosen for desaturation, and the material parameters for Akita sand are used. And the material parameters for Akita sand that are used in the one element simulation are used in the dynamic analysis. So in this case, in this simulated case for the embankment, we are varying the degree of saturation to see how the embankment will behave under these two input earthquake motions. Okay. So in the dynamic analysis, I choose to okay. So for the simulated cases that I used, I chose some critical points in the embankment where they are susceptible to damage when earthquake occurs, and I used the desaturation concept for air bubble injection to do simulation, and I picked up 3 elements along the center of gravity of the embankment so that I will see how the embankment, the deformation pattern can occur when earthquake occurs, and to test to see if this air bubble injection is actually an effective countermeasure for liquefaction damage or not. So in the deformation, after the dynamic analysis, we found out that in the deformation patterns after we used the input earthquake motion of Kobe to 1995, we saw, if we look at the result, we will see that we are going to see that the deformation pattern for the first case, that's A1, going to A2, going to A3, going to A4, they have different modes of failure patterns. Now, these failure patterns are the patterns that we can use in order to determine what particular surface area we are to use the desaturation concept to improve. So similarly, when the 2011 Tohoku earthquake motion was applied to for dynamic analysis, we also observed that the failure patterns as well for the improved area, for the improved areas in green, had I think for a longer earthquake motion, because this 2011 Tohoku earthquake it lasted for over 4 minutes, about 250 seconds. So the earthquake motion after improvement of these embankment models showed that the desaturated areas were more effective than the previous earthquake motion. But now, for us to be able to ascertain whether or not the embankment is liquefied, we all know that when the effective stress decreasing ratio for the embankment equal to 1, then the embankment is completely liquefied at that point. So utilizing the 1995 Kobe earthquake motion in the embankment models, we can see keeping the degree of saturation constant. We observe from these diagrams that when you look at the case study of case 1, which is not improved area, you find out that the center of gravity of the embankment has some some points of being liquefied. So, but as the density of the color from blue to red goes from case A1, 2, 3, and 4, we realize a drastic reduction in the liquefied area, right up to where we observe that the lowest density of the color range shows in case A1, 4. So the graph for the effective stress decreasing ratios are shown for each of the various cases, and we observe that the case A14, which we saw the variation in the evidence of liquefaction has the lowest effective stress decreasing ratio and also is the best improved area for liquefaction. So similarly, when we apply the Tohoku earthquake input motion, we observed that the effective stress decreasing ratio graphs for the case A21 right up to A24 has similar patterns, but in this case, the case A24 also has the smallest effective stress decreasing ratio, which shows that the lower the effective stress decreasing ratio for the embankment after dynamic analysis, the higher its liquefaction resistance. And we also have there the lowest effective stress decreasing ratio, and it also shows the best improved area. So when we look at the various improved areas, the smaller part in the center of gravity at the toe of the embankment and all spread all through beneath the embankment, we realize that for both the input earthquake motions for a longer and a shorter span earthquake, the one that has the improved area right beneath the embankment entirely has the most improved area from the results. So when we want to do, when we want to check Okay, so when we want to check for the damage level for the embankment, we check from the settlement comparison. It's not changing with this one. Okay, these are the effective stress decreasing ratio for the different improved area configurations, and then for the settlement comparisons, we look at the settlement comparisons, and we also see that in the case of, just a moment. Okay, we also see that the best improved area here has a degree of saturation of 40%, which shows that as we are lowering the degree of saturation, the liquefaction resistance is also increasing as well. So analysis from both input wave motions shows that the case C4 with a degree of saturation of 40% has the smallest settlement. Similarly, with regards to surface area, we see that the surface area improved all through beneath the embankment has the best improved area using this air bubble injection. So the conclusion for this work is that the conclusion is that the settlement of the embankment was reduced approximately by 81% when the Kobe 1995 earthquake motion was applied, and reduced approximately by 85% when the 2011 Tohoku earthquake was applied, when considering air bubble injection as a countermeasure for liquefaction damage on the embankment. And the most effective, it was most effective over an area of 5 by 35 meters with an optimal degree of saturation of 40%, judging from the overall results simulated with both input motions. And then, but there is a need for parametric studies for the other two materials, that's the Toyora sand and the Edosaki sand, to obtain the improved results. So the material parameters for all the samples that were used are there on the table below. So that's all for my presentation. Thank you for your attention. We have some references.
Thank you very much, Engineer Ajendia. You observe that this is purely modeling and simulation. So if you are not mathematically tuned, if you don't like simulation, you may find it, you may not find it, well, maybe let me say you may not find it interesting, but it's deeply interesting because that is the way engineering is going. It's not just Santita cos theta modeling simulation. So let's have questions. Yes, number one. Thank you, sir.
Yeah, thank you for your presentation. Yeah, I have 3 questions here. The very first one, given the case of Akore, which we have just seen, where the soil classification is under class A1, A2, purely granular material. And if you have the saturation of 100, and given the Kobe earthquake, which you have not mentioned the magnitude, but I believe is about to 7.1 strong ground motion, do you think liquefaction will occur in Akore, which has just been presented? So the second question is you use the Kobe earthquake, which is a strong motion. As far as I know, is Ethiopia that is prone to earthquake. And the motions of these magnitudes have been going to about 6.9 and is a weak motion. The first time it experienced a strong motion was about 2016, which was a motion of 4.5. Now, how you use this Kobe earthquake, how did you fit that to the Cameroon situation, which might have not experienced any strong earthquake? So the next one, in order to incorporate earthquake to your model, which type of model did you use for the earthquake?
Please respond. Thank you.
Thank you very much for your question. The first question which you asked regarding if the Kobe earthquake was, if it happened in Akoli, is that right? Am I right? If it happened in Akoli, is there a possibility of liquefaction to occur? The answer is this. First of all, we need to understand the geotechnical materials found in that locality, because the process by which soil liquefaction mostly occurs in sandy soils. And before liquefaction occurs, there is supposed to be a build-up of the excess pore water pressure, and then the effective stress of the soil is reduced essentially to 0 before liquefaction occurs. So it all depends on if the geomaterials in that particular area is sandy, first of all, and if after the earthquake occurs, there is a build-up of excess pore water pressure that leads to the effective stress decreasing ratio of the soil to go right down to 0. If that happens, then there is a possibility for liquefaction to occur. In your second question, but first I want to verify if you are satisfied with the answer.
Actually, the material has been classified already and falls under class A, A1 or A2. That is how the material was classified. So that alone is enough. So there is no material characterization that is needed to tell whether it will occur or it will not. So, but the material as classified is enough to know the situation. and we say the saturation can be 100%, and you say it is dependent on the saturation.
Okay, now when you look at the case studies in this study, it has, as you mentioned, A1, A2, A3. These are not material. These are embankment model cases, like case 1, case A1, case A2, A3, and A4. But if I get you correctly, you are trying to ask if you are trying to ask the possibility for liquefaction to occur with a particular soil, right? So the possibility for that to occur will depend on the soil parameters which we are using as a basis for this study. That's the degree of saturation of the soil, and as well the pore water pressure of the soil, which I've earlier shown in the slide which we were doing the numerical modeling formulation. So there are three principal things which we are looking at in this study. We are looking at the pore fluid compressibility, we are looking at the degree of saturation, and we are looking at the bulk modulus for the air-water mixture. So in answering your question, I will repeat again that the probability, or maybe the likelihood for liquefaction to occur in a particular soil sample will largely depend on the type of soil, the bulk modulus for the air-water mixture, and the degree of saturation.
Thank you, Engineer Ajende. Just one more, snappy, because we only have 2 minutes before we have our keynote speaker speaking from UK.
He has 2 more questions.
Oh, 2 more
that
questions.
he has already with him.
Okay. 2 more questions. He has not responded.
Please, can you come over with the other question?
Okay, the second one, you use that earthquake for modeling the Kobe earthquake, about 7.1 strong motion. How did you incorporate that earthquake to fit the situation in Cameroon?
Okay, in a situation where the Kobe earthquake of 1995 occurs in Cameroon, I think that most of the areas which are susceptible to liquefaction in Cameroon, we have the Douala Bay area, where most of it is the coastal region of Douala going towards Kribi, most of which they lie on sandy soils. I think that if an earthquake of such magnitude should occur, that is the most susceptible area which will be affected. And in utilizing this study, I think that because this research entirely is a pre-disaster research to envisage in a case where earthquake occurs, so it's not a post-disaster research. So in that case, if such an earthquake occurs in Cameroon, we are going to take watch of all the high-rising buildings that are built along the coastal area of the Douala Kribi Bay, where they lie mostly on sandy soils which are susceptible to liquefaction.
Actually, what is going to happen in order to improve your work? So we have an input, which is a wave like this. Yep. And that is the one with that magnitude, 7.1. Now, when you put that to your model, then you have to know the ground acceleration for Cameroon, and then try to scale that input to your ground acceleration before you run the model to give you the output. So by that, you have actually brought that use an earthquake from another country, and then you're trying to fit it to the situation of your country.
That was quite a contribution I didn't envisage. Thank you for your contribution.
Yeah. Okay, fine.
Thank you very much. I think it's not only for Cameroon. Recently we had, well, will I say flash earthquakes in some parts of Nigeria. So I think what you have suggested would be good to scale down to the situation of different areas, different countries that are, well, prone to earthquakes. But unfortunately, well, interestingly, in Africa, we don't have many of such countries, but we are beginning to see flashes of such things in some parts of Africa. So I think you can take note of that and improve on the work. Thank you. So Engineer Agendia, we can ask you to go and sit down so that you enjoy your lunch. Interestingly, I didn't see my students asking questions. It's too technical for you. Well, that's the way knowledge is going. Modeling, simulation. Okay, so please, you can read more of that. Thank you very much. So we wait for our keynote speaker to join us in the next 3-4 minutes. Let's be patient. We should actually be going for lunch, but let's have him. Then we'll have 2 more papers when we come back from lunch. Thank you very much. Ladies and gentlemen, let's settle down so that we can have our keynote speaker to present, to give us the speech on scientific research as component of the threefold mission of a university and its contribution to the enhancement of the quality of teaching and learning civil engineering. He should have presented on the day 1 of this conference, but we are having him now. So I welcome Professor Goz from the University of Aberdeen, UK. Thank you.
Good afternoon, everyone. It's my pleasure to give this presentation today. I just need to share my screen and can you see me now?
We can see your screen.
Hello, can you see me?
Yes, we can see your screen.
Hello?
Hello, hi to people.
Yeah, yeah. Can you just confirm whether you can see my slides, please?
Yes, we can see your screen.
Okay, excellent. Okay, so good afternoon, and what I was asked to talk about, and very happy to share my thoughts with you on research and curriculum development opportunities in the era of Industry 4.0, which is linked to research as component of the threefold mission of a university and its contribution to the enhancement of quality of teaching and learning in civil engineering. First of all, this term industry 4.0 or the fourth industry revolution, it's a relatively new concept, which the best probably characterized by the words of former US Secretary of Education, who in 2014 said that we are currently preparing students for jobs that don't exist, and sorry, just my screen disappeared. Just a second. Right, so the former Secretary of Education in the United States, who said that we are currently preparing students for the jobs that don't yet exist, using technologies that haven't been invented in order to solve problems we don't even know are problems yet. And in such great uncertainty, which we are all facing in developing research and education, Industry 4.0, this term which was coined by Kagerman in 2011 when referring to the industrial revolution, where technology will not only increase resources and time efficiency, but will also change the way people work. This schematic gives some idea of how those four industry revolutions that humankind went through are characterized. Industry 1.0, when mechanization happened, steam power, weaving loom. Industry 2.0, when mass production started, assembly lines, electrical energy. And Industry 3, it's automation, computers and electronics. That's what probably happened 20-30 years ago. Industry 4.0, cyber physical systems, Internet of Things and networks. What is characteristic of those industry revolutions? This is a very important schematic which shows how usually our knowledge and education and technology are developing over the years. It's not going in the same phase. It's not going simultaneously. If you look at, for example, the blue line, the development of technology, at some point there is a step change, and the yellow line, which is education, does not necessarily follow entirely that line. There is a mismatch. And this is exactly the period of industry revolution, when education not catching up with technology, and that leads to a very significant social pain in society. When education catching up with technology and going ahead of technology, that's a period of prosperity for a society. Then again, we have a step change in technology, when sometimes we think that we don't even need it. Education still lagging behind, period of social pain. So that's the role of education right now. After a very significant step change in technology, we need to advance our education to catch up with technology and to reduce social pain, and which will lead to prosperity. So in the age of the fourth industry revolution, the main research challenges are related to the exponential growth of digital tools, robots, connected objects, communication systems, data centers, and associated industry consumption. In the same time, industry needs manufacturing professionals which are highly skilled, flexible, and emotionally and socially intelligent. For workers, there is a need to take personal responsibility for their learning trajectory and embrace the concept of lifelong learning. This is one of the major changes and the major characteristic of Industry 4. Personal responsibility of the workers for their lifelong learning. We cannot have just one period in the life of a person, when, say, from 17 to 25, when they go to the uni, having their degrees. No, it's lifelong learning for everyone, not just for academics. And the skill requirements are changing rapidly. That's the reason for needing lifelong learning. It is crucial to support upskilling of workforce towards the new and higher skilled roles. Reshaping the research agenda and teaching curricula is a considerable challenge anyway, which implies complex decision-making processes and various admin obstacles. Many higher education institutions are still dominated by traditional approaches to subject-related silo thinking, while the new industrial age requires fundamentally new mindsets. So we have almost a perfect storm, rapidly changing world, and also rapidly changing frameworks, national and international frameworks, both within and out with the higher education system. What we need to do, and that's our task, is to capitalize on those changes and use them to our advantage. How we can do it? There are 4 pillars here. Excellence in research and enterprise. We need to develop strengths in challenge-led research for addressing key issues of our time. Environmental sustainability, decarbonization, and digital transformation. I will talk more about challenge-led research later on. We need to be pioneering in education, respond to higher education needs of a changing world population. We need to look after our communities. We can only flourish if we have flourishing communities. We need to focus on positive impact, to pioneer technologies not just for their own sake, but because they help to improve society. Only those technologies are worth investing in and developing. And of course, we are in globally connected world. we need to be globally connected as an educational establishment, as a university. We need to build sustainable international partnerships that expand the horizons of our staff and students. How it can be done in practice, I can try to share some of our experience in Scotland, how the changing, sometimes very dramatically changing external environment, how the changes in external framework, how they affect our way of thinking, and how we can adjust this to use it to our advantage. Very recently, just 2 months ago in September, the Scottish Funding Council, and this is the organization which looks after funding for the university, both for teaching and research, issued a report on review of coherence and sustainability of Scottish education and research system. This SFC review of coherence and sustainability had several topics which Scottish Funding Council would like us to address. The first and probably the most important, which is called towards a responsive, coherent education and skill system. Focus is on place-based collaboration. Focus on working together, university with employers, to adapt and to respond to the local needs. So we are talking more and more in Scotland about focusing on our local Scottish needs. Learning throughout life. There will be a national micro-credential framework and the upskilling fund, very important funding to support this. Nationwide system of lifelong learning with mutually recognized credits, so you can do different parts of your education at a different time of your life in different institutions. National estate strategy, digital development, net zero emission and low carbon estates projects, which will be supported by the state, and this investment is something that will move us towards the net zero targets. Also, collaboration to seek further efficiencies. Scotland is a small nation, so duplication of teaching efforts sometimes are not optimal. We need to look at class sizes, remove any duplication in the curriculum, have a proactive approach to program portfolio management. Another pillar of this new approach advocated by the SFC, it's sustaining research and enhancing knowledge exchange. We are not talking just about research anymore. We always look at enhancing knowledge exchange as well. Research pools will be recommissioned to strengthen interdisciplinarity and to strengthen interdisciplinary challenge-oriented research collaboration, leveraging additional funding and fostering early career research communities. Challenge-oriented research, that's something that we were dealing with or rather responding to the government initiatives for the last 10 to 15 years. Now we are moving to mission approach for research. Overall, the balance of strategic funding shifting from research to knowledge exchange and innovation. Another report, which was produced by the principal of Glasgow University, Muscatelli report, says that evolutionary approach to focusing on areas of critical mass for innovation to gradually sharpen the focus of Scotland's innovation strategy, funding for transformative research and innovation at national level with long-term outcomes and impact. One of the missions which will be pursued is to focus on net zero and just transition. Also, embedding enterprise education through the concept of entrepreneurial campus, where students will have opportunity not just to learn, but to put their knowledge in practice, not just engineering practice, but entrepreneurial practice, developing their companies, their new ideas. And to illustrate what does it mean to have a mission-led research rather than just a challenge-led research, if you look at Horizon Europe, this is a pan-European funding framework. They have five missions. By 2030, adaptation to climate change. Adaptation to climate change, this part is the challenge. However, it's not formulated just as a challenge. It says adaptation to climate change, supporting at least 150 European regions and communities to become climate resilient. The second part of this, it's already a mission with a very particular, clearly defined objectives, targets, which we need to achieve. The same as the second mission, cancer, improving the lives of more than 3 million people through prevention, cure, and for those affected by cancer, including their families, to live longer and better. Restore our ocean and waters, or 500 climate neutral and smart cities. That's mission, 100 such cities. Similarly, this mission-oriented and challenge-led research is formulated in the strategic priorities of United Kingdom Research and Innovation. 34 programs organized under 8 themes: environment, biology and biomedicine, artificial intelligence, productivity, infrastructure, health, well-being and human rights, digital, productivity and technical. And I am absolutely sure that civil engineers can contribute to all of them. Some other aspects of this new approach advocated by the Scottish Funding Council, protecting and promoting student interests, which is another very important aspect. Widening participation and articulation, like engineering academies, and very clear target for each university to increase the intake of students from underprivileged backgrounds, say moving that target from 10% to 15% for each university. Also clear definition of frameworks for the future. There will be new national impact framework, which will be linked to Scotland's national performance framework and the underlying United Nations Sustainability Development Goals, which will allow to demonstrate longer-term impact across a broad range of outcomes. And very importantly, institutional performance that meets or exceeds expectations set out in the National Impact Framework will be rewarded by the Scottish Funding Council. So it's a significant gain for any institution which is at the forefront of this development. So developing research and curricula for our uncertain world sometimes is characterized by this word WACA. The term is gaining popularity now as a notion that covers the various dimensions of of this uncontrollable outside world, volatility, uncertainty, complexity, and ambiguity. So providing relevant education in this VUCA world requires a mindset shift with an aim to convert uncontrollable chaos into manageable complexity. Complexity will still be there. The latter can be achieved with the help of the following four elements: vision, understanding, commitment, and agility. The same VUCA, but a positive one. I do have several more slides detailing how the Scottish Funding Council suggests to progress in this direction. So when my time is up, please let me know that I can stop. The strategy is teaching new skills and teaching skills in a new way, preparing students for lifelong learning. I'm saying this several times today. Very important shift to lifelong learning. Offering big picture education, the educational offer which fits into the overall learning trajectory and labor market, considering societal needs, sustainability, ethics, and learners' needs, individual characteristics, for example, respecting diversity of learners' contexts and capacities. Shifting from knowledge towards competencies. We are not talking just about knowledge for the knowledge sake. That's very topical for any civil engineer. Competencies, ability to do the work required, ability to contribute to developing technologies and building society. Offer relevant, personalized and personal learning. It's not just lifelong learning, it's personalized lifelong learning. Personally tailored for individual capabilities, individual demands, individual situations. Actively engaging learners in curriculum development. We need to know what our customers, our students would like to know. Upskilling teachers. We cannot improve education without improving our own skills and equipping them with the right tools to teach students the new skills. Also incorporating non-technical disciplines into curriculum in order to develop cross-cutting competencies beyond technical expertise. Teaching how to acquire knowledge from the ever-increasing ocean of data, how to find out what to make of it when it has been found. Teaching specifically about the necessity of maintaining good physical and mental health. All countries are now, especially post-pandemic, suffering from explosion of mental health issues. Problem-based learning, creating a culture that accepts potential failures and developing the ability in students to turn those failures into valuable learning experiences. That's something that we're not necessarily doing well in Scotland. There is certain fear of failure in children starting from school age. That's not good for engineers. We need to accept that there may be failures, not failures of structures, of course that's not acceptable, but failure of ideas. Not every idea will necessarily work. Encouraging collaborative learning by offering suitable physical spaces and virtual environments. And the last group of initiatives, collaboration. Increasing university industry collaboration in terms of both volume and diversity of collaboration forms, internships, apprenticeships, mentoring, project banks, think tank competitions, summer schools, creating more opportunities for exchanging experiences with other educational institutions, for example, via joint platforms, thematic networks, like we're doing now today, facilitating peer-to-peer learning to enable learners to learn with and from each other in other very, very important aspects, creating effective learning ecosystems that engage all key stakeholders groups, including education and training providers, industry, policymakers, and broader communities, and shifting from human-machine interaction towards human-machine collaboration. All these strategic directions, of course, good, but there is one more thing to mention before I finish, that all the strategic initiatives, good planning will fail unless we have the right culture for this. And it's one of my favorite expressions from a very, very well-known educationalist, Peter Drucker. Culture eats strategy for breakfast. And that's absolutely true. Unless we have right culture, all our strategies will go out of the door.
Hello, Professor Goss.
Yes, yeah.
You have 5 more minutes, please.
Oh, yeah, yes, I will be right on time, thank you.
Okay, thank you.
So developing a value-led culture with a focus on being people-oriented, innovative, and ambitious. We need to be collegiate and inclusive. We need to widen access to our education provision. We need to be open and transparent with clear communication, whether it's for our colleagues within institutions or to the world outside academia, wide consultations on important issues. We need to be very fair, including working with our colleagues, workload, promotions, clear and transparent performance measures and targets for institutions and individuals. And we need to care for well-being, health and safety of our diverse communities, supporting and developing our people to achieve their full potential. And of course, we should be environmentally and financially sustainable. So to finish with, culture will certainly eat strategy for breakfast, and unless we do something to change our culture and develop value-led culture, then all our great strategies will not work. And thank you very much for your attention. I appreciate this chance to give you some of my thoughts on research and curriculum development. And if we have time, I'm happy to take questions. And otherwise, I just wish you every success with your conference.
Thank you very much, Professor Goss. Do you have comments? Okay, okay. Please, Professor Goss has spoken about so many things, and if you listen carefully, one of the things he mentioned, which caught my attention, is the fact that we are in the fourth revolution, and the issue in the fourth revolution is, the fourth revolution is digitally controlled, and this is why we are our students that are just coming up where they come in, and there is another important thing which he said, that we should have new mindsets. We can't continue doing things as we used to. And, he presented the strategies that Scotland is, the strategies Scotland is following. Do we have strategies in Rwanda? Do we have strategies in Nigeria, Cameroon, and other countries, other nations in Africa? We can't rely on other people, other countries' strategies. We must come up with our own strategies. And I hope at the end of this conference we'll be able to think more about how to drive our economy in this fourth revolution. Just one question, because we are beyond one question or comment or observation. Yes, Professor Coker, I want you to talk.
Thank you very much, distinguished Professor Howder at the University of Aberdeen. I was really, really blessed by your presentations, and like I share with the chairman here, to be very useful for participants to be able to have a copy of this presentation, if you can share with us by email, or you share with him and then he shares with us, because you've really mentioned very pertinent issues. That's the way for us to go in all our institutions, especially those of us in developing country. At the University of Ibadan, Nigeria, we are currently working on redrafting, doing something about our curriculum in civil engineering, for instance. Practically most of my colleagues from the university are on that committee that I chair. And one thing is obvious. Some of us, it's so obvious that we need to have a change of mindset, like my colleague, Dr. Akintayo mentioned. And, you know, some of the things you said, it just struck me. Well, one of them was even was a statement made by the U.S. Secretary of State, and I want to read it again, that sometimes we are currently preparing students for jobs that do not yet exist, using technologies that are yet to be invented for problems that do not yet exist. So it's so important that, from one thing I gained from what we share today, is the importance of coming up with curricula that will be relevant to our society, something that will put food on our table, something that will be a blessing. Even in the way we do research, not just doing research that will just be good for chefs, but research that will contribute to solving global problems. And if you look at the recent scenario, the global pandemic, the COVID-19, has thrown up the need to think in this direction. It has thrown up the need for us to begin to get ready, because when the problem came out to the fore all over the world, each country was busy thinking about what to do to solve their problem primarily before they were thinking of solving it on a global dimension. And it makes sense. If you cannot save yourself, how can you save other people? So I think one takeaway for us in this program, this conference, is let's begin to think outside of the box. And even like somebody said, maybe we need to throw away the box and think differently, and particularly reposition our education for something that will sustain our development. Thank you very much.
Thank you very much. Thank you, Professor Goz, for that wonderful keynote speech. I think you can release it to go, and we have been waiting patiently to have our lunch. I think you can also go for lunch and come back in 1 hour's time to continue the conference. Thank you.
Distribute it in the conference. Thank you.
May I request you to get ready in 5 minutes so that we may resume our sessions? Those of you who are outside, please get ready in 5 minutes. We are starting in 5 minutes. Can we start now? Those of you who are outside, please come back so that we can start. May I request everybody to come back so that we can start? May you please have a seat? Those of you who are outside, please come back. Okay, I will start with an announcement. At the end of these sessions, we will have a cocktail at the Classic Lodge Hotel. We will go to Classic Lodge Hotel, not at the Fatima Hotel. Okay, so our guests, today you will not have a dinner at the Fatima Hotel. You will have, you will not have a dinner at the Fatima Hotel. You have one from another hotel. Okay, whose name is Classic Lodge Hotel. It's a different environment. We want you to get a different experience, not only to get a dinner from a different, the same place every day. No, we need a change, some change. Okay, so at around 5 there will be buses here who will transport us to Classic Hotel, all of us. So we have planned sufficient facilities for everyone who is attending physically this conference. So we will be there from 5 o'clock at the end of this session until anytime you want. So we will be celebrating that our plans have been going well, and we hope that the remaining sessions will also be fruitful. So with this, I wanted to invite the next session, which is going to be delivered virtually by Damirora, a speaker from Botswana. Is he around? IT team, can you check for me if Damirora is around? Damirora, is he around? Not around? Israel is Israel? Okay, maybe Israel. Is ready? Okay. Okay. So So we can welcome Israel.
Okay, do you want me to start now?
Israel, can you hear me?
I can hear you. Can you hear me? And do you want me to start?
Yes, you can start, but you try to increase your voice. We can hear you, but
Okay,
not very well.
I am speaking at the, yes, I'm speaking quite loud here. Can you hear me? Maybe increase the volume?
Check the volume of your speakers, yes.
No, I mean, maybe could you increase the volume on your end? I am speaking
Yes,
quite loud here. Hello, can you hear me okay? I'm speaking quite loud.
Maybe I can introduce you briefly before you can continue with your presentation. The speaker that is going to be with us now is called, his name is Israel Osofero. He is senior lecturer in the Department of Civil Engineering at University of Aberdeen in the UK. So he will talk about development of affordable indigenous construction materials, advances and challenges. Israel, you are welcome, sir. Please go ahead.
Okay, can you hear me better now? Hello, can you hear me okay?
Yes, you can.
Okay, thank you very much for the introduction. So I'm from University of Aberdeen, as mentioned. We operate school systems, so I'm from School of Engineering. So I will be presenting on the development of affordable indigenous construction materials. I'll be talking about advances and challenges. So just to let you know how this will go, first of all, I would like to talk about what we mean, what are we talking about if we talk about affordable indigenous construction material or materials. Why do we need these materials? Why do they need to be affordable? And why do they need to be indigenous? First of all, that's the main thing. Then I will talk about advances. I looked through the program of the conference and I see that a few presentations along this line, which is great. But then I will also talk about the challenges. So even at this conference already, a few people are already presenting around this research area. So what are the challenges? Why are there no uptakes of this? Why is it not being used today? Then I will conclude. Okay, can I just ask before I go on, how many minutes do I have for the presentation?
You will have 20 minutes for the presentation and 10 minutes for questions, open discussion. Thank you.
Okay, I will do my best. I'll do my best to keep it within 20 minutes. If I cannot finish it within 20 minutes, I will just leave what I cannot cover. I was working based on the 45 minutes in the program for 30 minutes presentation. So let's go on then. Don't let us waste more time. So what do we mean by affordable indigenous construction material? I will start by saying, as far as I'm aware, social housing is almost non-existent on the African continent. Maybe in some places, but not a lot. And so you have people that cannot afford housing. They cannot afford to have a house, and housing, food, and health are three of the main things that you need as human to survive. So we don't have social housing. Let's put it that way. Then we go to affordable housing. So a house that people can afford. So it's not just affordable. It has to be it has to be decent. Okay, so it's not just putting some things together and leave there. It needs to be decent, and I will tell you why it needs to be decent. I will go to why after this. Why do we need affordable housing? Why does it need to be decent? Why can it not just be anything? So to get affordable housing, especially on the African continent, construction is made up generally. Uh, the cost of construction is made up of two main costs. So you have the material cost, and then you have the labor cost. In the West, the labor cost is quite high, but as far as I'm aware, in countries around the Africa continent, the construction material cost is huge. Labor cost could be quite cheap sometimes. Either that is a good thing or a bad thing. That is left for discussion. But then we are at this situation where construction materials are not really affordable. They're quite expensive. They could be quite expensive. So take steel, for example. Steel, when you talk about reinforced concrete steel can be a huge part of your cost when you're building a reinforced concrete structure. And so if that is costing us a lot and is making housing not affordable, so why not look at affordable construction materials? And in looking at that, the best thing to look at indigenous material. So, and there are so many of them. I've put some pictures here just to show you some of them. They look funny. They look maybe interesting to some people. A lot of people must have seen this broom before or used them before. And they're from oil palm tree. They're called oil palm broom fiber, and you might not have looked at them as fiber before. It's just they're cheap. They are sold in the market, and for very cheap, actually. And you also have the picture on the left, which is sugarcane burgers. When you eat sugarcane, which is very nice, and then the shaft that you throw away, it's a waste. And how do you do with that? Can that be used? Can things like that? So it's just thinking generally. Could things like this be used in a way, in a rudimentary way, to reinforce structures? So the best thing to do is to think about it not from affordable housing. Start from indigenous materials. What do we have? What we have in different countries might actually not be any of the things I've listed on this slide, but the general idea of what do we have? Can we use what we have to get what we want in terms of use indigenous material to provide construction materials that are affordable, and then directly provide us with affordable housing. So why do we need to think about this? Number one, economic concerns. Like I said before, the cost of building materials going up. Why are they going up? Number one, we have material importation, and I will get to that. So I will take steel as an example again. We import steel. Well, the steel is manufactured. Sometimes we get steel on the continent, but we import almost the same amount as we produce. And because we import a lot of steel, we are affected by the material importation charges and things that happen. So if there is consistent inflation, there is a problem with that, because then it means the price for imported material will go high, coupled with many other problems. And I've taken this too from Google.com just to show us what's happened. So I've taken Rwanda franc and Nigerian naira, for example. In the last 10 years, Nigerian naira to $1 has more than doubled. That tells us something. Similar for Rwanda franc, it's kind of doubled in the last 10 years. So you see November 2011, and where we are now is the figure shown there. And also with that, we have poverty. A lot of people cannot afford to pay a lot to get housing. So, and then complication on top of that is that we have high population growth rate, and there is no minimal or no housing credit facilities like mortgage, and even people working and earning. How much are they earning? Can they afford to put something down for housing? Can they do it gradually? Of course, people do it gradually in their own way, in their own local way, but there is no organized, or there is not much organized credit facilities for housing. So that's economic concerns. Then environmental concern, which is really key as well. Steel production itself, if I go back to steel, still contributes a lot to carbon dioxide emissions. 8% of global carbon dioxide emission in 2018 contributed by steel production. World Steel Association says that. 2021, from Carbon Brief, 9% of carbon dioxide emission is from 553 steel plants, which is not even the whole capacity installed around the world. It's just represent 82% of that. Now, I was talking about steel transportation. So if you look at this from World Steel Association, so that's the crude steel production. We see the continent of Africa in 2010, we have produced 1.2% of the total world steel production, but we use finished steel product of 2.4%. And the trend has not reduced. It's a similar trend. In fact, was in percentage, if you want to look at it, as a ratio, that we produce now, 2020, 0.9% production and 2.0% usage. So that comes with a cost because we are transporting. It comes with environmental cost, and it comes with economy cost as well. Now, there is also health and safety concerns. Since this conference started, so it started on Monday, there has been a collapse in Ikoyi in Lagos, and that's on Gerard Terraces, and we don't know why yet, but what we do know is, although this is a large-scale one, there are so many small-scale collapses that goes on in many places, many cities, and even those ones that are not collapsed yet. There are so many unsafe buildings that people live in. Why? Because one of the reasons could be because, number one, people cannot afford the reinforcement that is necessary to keep the structural integrity of the structure, so they tend to compromise on material, and so there is health and safety concerns. And if there are no affordable housing, again, so look at the current pandemic, which thankfully it's I hope and I believe is going down at the moment. If you do not have housing, how do you social distance? How do you isolate? So it leads to so many things. If people don't have affordable housing, how it affects even the public health. So there are so many aspects to this, but because of my time, I will go on, and I will let you think more about this and how this can affect health and safety of a group of people. Now, if a lot of work has been done actually. So if you go to Google Scholar and you search reinforced composite, you will come up with so many things. It's like throwing everything at it. There have been a lot of different things that have been used to reinforce composite, particularly concrete and soil bricks as well. So you have things like waste tea. So it ranges from waste tea to human hair. Even people have tried to use this. You have waste tires and so many things. But what we are doing at the School of Engineering of University of Aberdeen is the focus for myself and my student, and in our little research group, the focus is fiber reinforced composite, and we are focused mainly on the natural fibers. Why? Because there's so many advantages of natural fiber. So it's environmentally friendly. Some of them are waste, and they are readily available, and even agricultural waste could be part of the natural fiber. And I have highlighted two projects here, and with credit to my PhD students that have worked very hard on this project. One is now a former PhD student. So natural fiber reinforced soil bricks. So we worked on soil bricks, on fired soil bricks. So what usually happens is you will fire soil bricks to use them in construction. And number one, that's expensive.
Can you hear me?
I can hear you. Yes?
So I have realized that we have got more time than planned. You can keep You can use 45 minutes or 50 if you want.
Okay, I'll keep going. Thank you very much.
We have got more time than planned, so please don't worry about the time.
No, that's fine. Thank you very much for letting me know. So
Okay,
I'll
cool.
keep
Thank
going then. Yeah. Okay, thank you. So like I was saying, Majub Saleh, who is now a doctor, my former PhD student, worked on natural fiber reinforced soil bricks, sponsored by Sudanese Ministry of Higher Education and the University of Aberdeen. What did he do? So what he looked at is soil bricks. Instead of firing soil bricks to make them stronger, why not use natural fiber to reinforce them? So it was quite an interesting project because he used sugarcane baggers and chicken feathers to reinforce these soil bricks, and then looked at what is the strength of these soil bricks if we use these common fibers to reinforce them instead of firing them. And the soil bricks have got to be fired at very high temperature, which, number one, it's not safe the way it's been done sometimes. Number two, it's not environmentally friendly, and it's expensive as well. So just showing you a few pictures of what was done. Compressive test, prism was tested to see the flexural strength of natural fiber reinforced soil bricks, and some numerical modeling was done, and design recommendations were put forward. But I'm not going to go into that in detail. I will give you a reference list at the end where more details about this project can be obtained. But what I'm going to dwell on today for the next 10-15 minutes that I have, or 20, is the natural fiber reinforced concrete itself, which was carried out by a PhD student, Emmanuel Momo. Is finishing up his PhD now, and is sponsored by Petroleum Technology Development Fund, PTDF, Nigeria. Now, before I say this, before I go into the detail of this project, because it's just an example, there are many projects that have used fibers or natural fiber to reinforce concrete or soil bricks or composite. Now, I'm aware that this conference is about sustainable development and civil engineering education, and about sustainable development. The question I have for everyone is, how do we teach civil engineering education thinking about sustainable development? When we teach reinforced concrete, for example, if you teach reinforced concrete, do we, and it's a challenge for you and for me as well, do we actually introduce our students to the possibility of reinforcing concrete with other things rather than steel? Do our students know that if they over reinforce a concrete structure, it might not fail, but it is not sustainable. You cannot just keep throwing everything at it. You cannot just keep you cannot just say, okay, double the reinforcement area and then you'll be fine. Do we teach them about that? Do we actually teach them about the impact these things do have on costs, on the environment? Do they understand that? And so I will leave that with us while we think about that, and then I will go into this project. There is a lot to go through here. So oil palm tree is available in many countries around the world. I think over 40 countries, and it's actually available in a lot of countries in Africa. Now, and from oil palm tree, we can get so many different things. So this figure here, which comprises of so many sub-figures, actually gives us a lot of parts of the oil palm tree and what we can get from those parts. So for example, if you take C, for example, that's the oil palm fruit. And from the oil palm fruit, we can get the oil palm mesocarp fibers. So if you take the petiole or the front of the oil palm tree, for example, which is our B, the leaf, from the leaf you can get the front, and from the front you can get oil palm leaflet, and from the leaflet you can get oil palm broom fibers. So oil palm tree is a rich source of so many things. Of course, there are a few things against oil palm tree and things like that in terms of I think it's deforestation and all those kind of things. But we have the oil palm tree. Oil palm is used in a lot of places in Africa, so the production of oil palm is continuing because it's a food source. And after the production, the leaves are left as waste. So, and then the oil palm broom fibers are actually gotten from the leaves, and they are used as just broom to sweep, and they're quite cheap. But they can be quite useful. And in this project, interestingly, we have gone and looked into what are the characteristics of these oil palm broom fibers. Can they actually be used? So it's their initial work. It will take a long time and a lot of work for us to get to the point where this can actually be used to reinforce your composite or concrete, for example. But let me continue. And I know possibly there are people here that are aware of this, that have maybe even read about this. And I will give a list of reference at the end as well, where you can find out more about this. So like I said before, what is the tensile strength of OPBF? So when we take a natural material, what we need to do is we need to understand, as engineers, we need to first of all understand the properties of this material. And that comes with its own challenges because they are not manufactured materials. They are natural. They occur naturally. And there are a lot of challenges with naturally occurring materials. I can just drop this here. One of the challenges is because you don't manufacture them, you lose homogeneity. So it's not, you cannot, they're usually not homogeneous. And even they change from a place to another. So it varies a lot. The variability can be quite high. So that's one of the challenges. And as I go through this presentation, I will be dropping one challenge there, another challenge there, and I will be dropping an advance here and another advance there, and I will also be dropping the pros of using these natural fibers as I go through the presentation. So I'm not gonna have a list at the end to say these are the pros and these are the cons. So I'm just gonna be talking about them as I go on. So tensile strength of OPBF. How do we know the tensile strength of OPBF? What about water absorption? Does that affect the behavior of OPBF? And that's not just OPBF, that's typical of a lot of natural fiber that is considered to be used in construction. So not a lot of studies have been done on OPBF before we started working on it in the project, and OPBF are usually recommended for non-structural application because the structural behavior is not known, so that's understandable. So what did we do, and how did we do it? So we did 3 things. The first thing we did was we looked at the OPBF material itself. Because like I said, that's the place to start. You need to understand the material itself, because if you don't understand the material, then you are not able to understand its behavior within a composite. So we looked at the cross-sectional area. It looks easy, just measure the cross-sectional area, but for natural material, it could be slightly complicated. Moisture content, specific gravity just shows us the ratio of its density, how lightweight is it compared to other material used in construction. Now we looked at the tensile strength, and then we looked at it from optical microscope to understand what's going on. Talk about the xylem cavities and things like that. And once the OPBF is understood, once the material property of OPBF is understood, that is only when it can then actually be used in conjunction with other material to form a composite. So we did this in 2 ways. So now the first way, which we have called OPBF concrete, is just to introduce discrete OPBF fibers just 50 millimeter in the mix for your concrete, and then to see what happens to that concrete. What happens to the compressive strength of the concrete? What happens to the flexural strength of that concrete, and the split tensile strength of the concrete? Then the other way is actually to then, and like I said, this is the first work done on this to actually create what is called OPBF tendons. And OPBF tendons is just basically taking each individual OPBFs and putting them together as tendons to replicate in a way to mimic the steel reinforcement bars that we have that we use in concrete. And having done that, then we looked at the pull-out strength of this tendon and also the flexural strength of concrete that is reinforced with this OPBF tendon. So let me take us through the result and the methods that have been used. Okay, and if you have any question, we have time at the end to discuss this. So I will go through this and I will just give you the summary of the result. So the cross-sectional area was measured and the values are given there. Moisture content is around 9.86, between 9 and 10. If you put it that way. Specific gravity 0.84, which is quite light actually. Because if you look at aggregate that you use in concrete, your specific gravity for aggregate will be 2 point something, maybe 2.65, 2.5 something, 2.7, thereabout. Now, a lot of specimens were tested to actually understand the tensile strength of OPBF. And this mean value of tensile strength, which is 372 megapascal, is actually quite conservative, and you will see why I say that later on in the next slide, I believe. Now, how was this done? So if you take a broom unit, for example, if you take it out and look at it, you will discover that the cross-sectional area of the broom actually reduces from this point, from the head to the tail. So what has been done is to divide it into 4 different regions, okay, of 150 millimeter each, okay, and tested different region of the OPBF itself, and that's what we have here. And we have used epoxy glue to make sure that the machine will not crush the OPBF, because if you don't do that, if the end is not strong enough, and when you put it in the machine, so that's where you have your failure, and that will not be representative. That's not what we want. We want tensile strength. We want failure to occur within the gauge length, which in our case is 110 millimeter. The other thing that was done is to actually look at this OPBF with optical microscopy facilities. So we use optical microscope to look inside the OPBF. And interesting thing is that although the OPBF's region A has got higher cross-sectional area, the cavity there is quite huge. Whereas as you go down the length of the OPBF, the cavity reduces in this magnitude from about 100,000 to 1,500. And that has got effect on the tensile strength. So the tensile strength of class D seems to be the highest, then followed by class C and B and A. So this is not showing the, what's it called now, the line pattern, but this is A, B, so the highest one is A, B, C, D. So this is just a typical tensile strength plot, stress strain plot for each class of the OPBF fiber. And then there is a plot here for tensile strength, a scatter diagram against cross-sectional area, and then there was a curve fitting done just to give an expression
of tensile strength in terms of the cross-sectional area. So this actually basically is just to show that the previous value of 372 megapascal mean it's very conservative. Okay, so once the property of the OPBF fiber themselves have been established, we then went on and did OPBF concrete. We make specimens were made, tested in the lab. So these are the constituents of the OPBF concrete. You have your fine aggregate. Okay, that should be your. You have your coarse aggregate. So 0.1 millimeter to 10 millimeter is coarse aggregate. You have fine sand, which is fine aggregate. You have OPBF, which is 15 millimeter, and then you have the general purpose cement. So a lot of testing was done. I will save you the details of going through each of the tests, but you can see that on the slide. A lot of testing was done, and 276 tests actually, and different properties were examined. Compressive strength, like I said before, split tensile strength, and they were done up to 112 days. The reason being that natural fibers are known to suffer from long-term degradation. Okay, so and that's for flexural strength as well, which was done up to 112 days. So let me talk briefly about the results. Actually, so what was observed is that as you include OPBF in your concrete, there is a reduction in compressive strength. This is not good news, of course not. But in a way, it's not good news. But if you look at it in another way, in line with other results that we share later, it's not too bad news. So at the end of the day, what we will be doing is we'll be sacrificing a little bit, but not a little bit, we'll be sacrificing some compressive strength for increasing tensile strength. And we all know that concrete is strong in compression, but very weak in tension. Okay? On top of that, the good news here is there is enhanced ductility when you include OPBF fibers in your concrete. So if you look at these cubes that have been tested and damaged, you see that as you move from control to inclusion of OPBF fibers and the percentage inclusion of OPBF fiber increases, you will notice that there is enhanced ductility in your concrete OPBF concrete material. So that means there is improved energy absorption with increasing OPBF content, which means that if we look at this very well and we do more work on this and we study it very well, this could actually be good news for low cost, affordable construction material for seismic application. Okay, so I'll go on then to splitting tensile strength. It's very difficult to test concrete in tension because you need to think about how you're going to pull it. You make a mold. It's possible, but it's very difficult. Okay, and we could discuss this after I finish my presentation. So what we did was splitting tensile strength. It gives an idea of the tensile strength of the OPBF concrete. Okay, and as we can see as well that there is actually, so from the control, this is the control, we do not have much improvement as well in the splitting tensile strength. But what we do have is we have what is called bridging action of OPBF. Okay, so the tensile strength value does not go very high. In fact, in some cases, as you keep increasing OPBF content, it reduces. But then there is bridging action, which makes it ductile. So at the end of the day, this ductility, it's really important, and I'm emphasizing it, and I will still talk more about it. Okay, and then we then looked at the flexural strength. as well. So flexural strength, actually there is an increase in flexural strength, which is great, and that increase also we see with age, which is great as well, because like I said earlier, the problem again is the degradation of natural fiber with age. But in terms of flexural strength, there is an increase. Of course, there is you will notice from the plot here that there is a decrease with with um, with percentage increase in percentage inclusion of OPBF. So at the end of the day, one has to think, what is the maximum amount of OPBF I should include in my concrete for me to get what I want? Then I spoke about Dr. Failure before, and that was, if you look at this graph at the bottom right, you will see the toughness index. Toughness index is basically measuring the toughness, which is the area under the stress strain curve of OPBF concrete, and then non-dimensionalizing that with the toughness of the control concrete. And that is why when there is no OPBF, the toughness index is 1. There is an increase, clearly increase in toughness index due to the ductility, but there is a decrease with time as well. But the good news is still, even with decrease with time in long term, the toughness at any point with inclusion of any percentage of OPBF is still more than the toughness of the control specimen with no OPBF. Okay, of course, then we need to look at the bond as well. So bond strength was examined, and bond test was done in the lab. And again, there's problem with that in terms of long-term bond strength. So there's degradation problem, again, showing its face. And then these are just surface response plots, like I said before, to have a combination of what do I need? Do I need to optimize my toughness if I'm using this material in seismic region? Optimize my toughness with time, or do I need, if it's not in seismic region, do I need to optimize my flexural strength with time? And then that can actually give an indication of the best amount of OPBF to be used. Now, the second part of this, so I've talked about OPBF concrete, which is just using OPBF as part of the constituent of your concrete mix. OPBF reinforced concrete is different. Basically, what we're trying to do is to develop OPBF tendons, which will actually then be used instead of steel bars in the concrete. It's a novel idea. It's in its infancy, but it's not too bad what has been noticed. So basically you have OPBF tendons, just putting the OPBF fibers together and using hose clamp to hold them together, and then you have your concrete, and then you use it to reinforce your concrete. So to do this, of course, for the tendon, we need to know the compressive and the tensile behavior of the tendon, as you would for your steel bars. And then so compression test and tensile test were done, and that's just a video of your compression tests. So let me show you. I will just forward it so that you can see it as compression tests. Okay, and then bond strength were examined again by a pull-out bond test in the lab as well. So some of these problems that I've talked about for OPBF, degradation, long-term strength, can actually be overcome by treating your OPBF. So we did some tests. We used hot water, alkali treatment, and saline treatment as well. And it can be seen from the maximum bond strength that there's an enhancement in the bond strength at 112 days based on the treatment. Okay. So then, after that was done, we also then did flexural testing by actually using the tendons as a reinforcement in concrete. What was realized is that you need a lot of OPBF tendon in terms of area for you to have the same behavior that still we give you. But that's fair enough. Come on, OPBF is available everywhere. It's natural material, and yeah, if that's what it takes, maybe that's a good start. Of course, there is a problem with reduction in the flexural capacity because of reduction in bone strength with time as well. And we concluded from there that maybe it's better for now to limit OPBF tendon to light structural members. So, for example, lintels in residential houses rather than using it to reinforce beams and things like that. So I will show you another video of the flexural test, and I'm fast forwarding it because of time. And you will see that it actually behaves, the behavior is quite similar to when you have steel reinforced concrete. And we have a deep shear failure there because there are no stirrups. Okay, so steel reinforced concrete was also tested, and that's the kind of behavior you would expect because you don't have stirrups or shear reinforcement. Okay, so I'm going to end with this. I know I've spoken a lot. So there are so many things I could speak about with the OPBF reinforced concrete and the OPBF concrete and natural material reinforced OPBF. But I know you are aware that there's a lot of work that is happening across countries, across Africa, in many countries, even in Asia, about this. But then the problem is, why has this not taken off? Because this has been done for many, many years. Many years, you'll be aware. There are problems with natural fiber themselves. The natural fibers that are being used have got problems themselves, like high water absorption. You have dimensional instability, I've said it, durability, long time strength, and then treatment methods have been looked at to see how this can be overcome. So sometimes it leads to reduced workability in fresh concrete, variation of the properties, degradation, reduction in compressive strength, so many. But I want to focus more on the society. I struggle with what to call this right-hand side list. I call it political and societal. At some point, I call it order. But let me leave that title and let's look at the content. There is lack of research support. And why is there lack of research support? Because we have weak industrial academia link. We can't stay in our labs and do all this work and say, okay, if you increase this amount of, if you put this amount of OPBF, you will have this amount of increase in strength, and this is what we need to do, and it can work. But if there is no buy-in by the industry, it's just going to be a research paper. At the end of the day, we're just going to have loads of research paper. There has to be a buy-in from the industry. The industry have got to be included and be a part of the process of developing these materials before we can see a change, and before we can see acceptability. So we are not just going to keep doing this and just give it and publish enough papers and people will start using it. Because number one, this has to be tested. This has to go through rigorous testing and things like that. The industry have got to see that it works before it can be used. And on top of that, and I put this here, I wasn't sure if I should put this. Is there a political way, the government, to actually support things like this, to actually look at the fact that we do not have enough housing, or the housing that we have, they are not affordable, maybe that's the word, and to support this kind of work that would then make sure we can provide affordable housing for the populace, especially those that cannot afford it. Now, there could be vested interest as well. So maybe somebody is importing steel and then you're going to get that person out of work. So it doesn't make sense. They won't want to support you. And here I've also put research commercialization, which is linked to the weak industry and academia link. Because if we don't have good industry and academia link, we are just doing research for the purpose of doing research. We are not commercializing research. We are not looking carefully at how our research can affect the industrial practice. And then again, we are dependent on foreign design codes. And natural materials are not used yet. There is no need to use natural materials in the West. So, and we are depending on the West for codes. So who is going to develop the codes that we will use for our developed affordable construction materials if we are dependent on the West for codes? So it's high time we start looking at how do we develop our own codes? How do we look at indigenous design codes in terms of what works for us? Of course, taking guidance and help from well-developed practice somewhere else. So I will conclude generally by saying that there is scope. I believe there is scope for development of affordable and indigenous construction material across the African continent. There is substantial volume of research, but there is no coordination towards commercialization. Everyone is just doing their own thing. In this conference alone, there are like 4, including mine, of presentation about, okay, if you change this, if you change that, if you use this material that we have in our country, then you can produce something that is cheap. Are we just doing it to increase our number of papers? Are we doing it to actually provide solution? There needs to be coordination towards commercialization, towards industrial uptake. That's the only way we can actually see real development of these affordable indigenous construction materials. Academic research is essential. I'm an academic, so it's essential. We need to keep doing what we can do, but we need to keep seeking industrial input. If you have access to present things to the government, we need to keep doing this, and we need to have professional organization buy in to see real progress. But nevertheless, there are many issues, but let's start wherever we can. Let's keep talking, let's keep thinking, let's keep doing what we're doing, but let's do more. Let's think about how this can become a reality rather than just a research paper or conference paper. So I've got a long list here of our output in this area. Everything I presented today, you can find more detail in this journal publication, book chapter, and conference proceedings, and there are references as well. So that's the end of my presentation. That's my email address if you want to keep talking about this. I don't have all the solutions, but we can discuss, we can see what we can do. So do you have any questions? Thank you.
Thank you, Dr. Israel, for your beautiful presentation. And I want to start from where you ended. Let's start wherever we can. So we want to start by asking you questions, making suggestions, and other comments. Audience, yes, I can see many hands raised up. I'm going to start with Dr. John. Dr. John, yes, I know the structural people researchers are already raising their hands, so we want to, Dr. Israel has put a poser. Let's start wherever you can. We are starting right here in this conference. So, Dr. John.
Okay, thank you very much. That was actually a very interesting topic. So, I spent in my PhD thesis, I was working on FRP, the fiber reinforced polymer. So I want to know the fiber, the natural fiber he's developing, he's using. So how are they related to the FRP we know? Because the FRP is too expensive, and his idea actually can replace even FRP, which is too expensive. And we have seen a lot of researchers using FRP as a reinforcement, and now his OPBL fibers, so they can do the same. So that's the first point I want to clarify. And the second is, in his experiment, actually he tested a very small scale. So, but if you test a small scale, it's very difficult to apply that for the full scale. So what if we can have a full scale beam, with those natural fiber reinforced, and so that we can see whether we can actually replace reinforcement, with those fibers. And also, I want to ask about the shear resistance, if they can contribute on shear failure for concrete beam. Yeah, thank you.
Thank you very much. Yes, do we take all the questions, Dr. Israel, or you want to respond to this one?
I will respond to this one because
Okay.
this is like 3 questions in one.
Okay.
So,
Okay.
and they are fantastic questions actually. Thank you for those questions. The first question is about FRP. FRP has been around for a while. So I have myself worked on FRP. I've worked on carbon reforms, polymer. I've worked on glass. I've worked on there is basalt. So there are so many different FRPs. They're fantastic, but the problem with FRP is they are engineered materials. They have you use epoxy a lot of times for FRP, if not every time, and they're not environmentally friendly. And we're talking about natural material here. FRP is not natural material, as it were, not necessarily natural material. Okay, so that's one thing. I wouldn't go as far as saying it will replace FRP, but I would go as far as saying that that's something that is being looked at. If successfully, I don't know, it can replace what's it called, steel rods in concrete, which it's got so many challenges. It's got so many challenges to overcome before we can make that claim. FRPs a lot of times are used to reinforce composite as well. So in similar vein, it possibly can be used in that line. So that's your first question. Is that okay? Do you get my point on your first question?
Yes. Who again is asked? Okay, Dr. Tak. Okay, let me start with Dr. Labiron.
To Israel. Thank you for the presentation. I just have a few, you could say, questions. You mentioned about these fibers that you have applied them to cubes. They were about 50 mm long. Did the orientation of the fiber matter, or is you just throw it in, or how did you keep them aligned to the stress path? Because that's usually the problem with natural fiber, number one. Number two, I see you trying to use it for pre-stressing, and you are holding them together with steel ties, I think. And combining a steel tie with it, is it not an anticlimax? And then how do you standardize? How do you make sure that the lengths are the same? I get some broom from the fiber I have in my farm or from the tree I'm getting it from. How do you standardize it? How do you ensure the diameters are the same, the lengths are the same, the surface is the same? Thank you.
Questions now?
Okay. You still want more questions?
Yep.
Okay.
No. Let me respond.
Okay.
Is that okay? So I'll come back to the second set of questions. The first set of questions was talking about small scale. Small scale, and it's linked to the second actually. So when it comes to compressive strength, the standard is 100 by 100 by 100 or 150 by 150 by 150. But for flexural behavior, yes, it was small scale. But remember that this is the first time this is being done, and large scale should happen. But you need to start somewhere. You need to look at this behavior from somewhere. So large scale should happen. In fact, what should happen at the end of the day is to have a proper, don't let me say proper, a full scale experimental investigation looking at high level instrumentation to look at the long term behavior of this fiber in your structural component. So yes, I take the point. So large scale should happen, and then from there we see if this small scale can replicate the large scale behavior. For shear, we have not used the fiber for shear because we can't do everything within the time we have. That will be an ongoing thing. Then if I go to the second set of questions in terms of standardization, that's what we are talking about. So standardization in terms of length is not it's not a worry, and I will tell you why it is not a worry. Number one, so if you look at when we did the tensor test for the fiber, we did it for a particular length. Okay, so we did it for a particular length, and we did it for a particular region. So this will eventually lead to standardization. And you're talking about the area. If you look at my slides again, which I can show you, although I'm not sharing it anymore, which I can show you, it's got developed expressions which needs to be the reliability needs to be validated with time, expression to relate area with the tensor strength, because it's understandable the area will vary, and that's why you don't just do it for a particular area. You standardize it, you non-dimensionalize it, and that's what we were trying to do. And lastly, on that question, there was a question about random distribution of fiber in the OPBF concrete. Of course, what we did was random distribution of fiber. I don't think it's worthwhile to actually arrange the fiber in the concrete. In fact, are you going to do that in practice? So what we did was random distribution of fiber, both for the experiment and for the FE simulation. I have not presented anything for the FE simulation because of clearly there is not enough time to get to that. And in further design examples and things like that, and those ones you can read later once they are out for people to read. Okay, I don't know if that answers all the questions.
Thank you. Just one more. Dr. Taku, please.
Thank you, Dr. Israel, for a good presentation. My worry is in two areas.
Sorry, Dr. Taku, make it snap.
Okay, durability and sustainability. We know that these organic products could decay over time. We use palm fiber in our villages as brooms. I know that as they come in contact with water over time, they spoil. How do we take care of that? And then secondly, I can imagine a number of palm trees that we need to have to make fiber enough to reinforce one building. How do we sustain this if we want to commit?
Quick response.
Yes, okay, I'll make it quick. The first question, I think I dealt with in my presentation. For the durability, I make it clear it's a problem, but there are treatments. I mentioned alkali treatment, saline treatment, hot water treatment, and I did not present much on that because with those treatments you can actually deal with the problem of durability. And we can keep looking at that, and there is durability problem. There is no way to hide from that, but treatment of these fibers will help. In terms of sustainability, which is a fantastic question, yes, the volume of OPBF you need to reinforce concrete is huge compared to steel. But my answer to that would be this. We already have these things. We are not growing palm trees just for oil palm broom fibers. They are already grown. We get oil palm from them. These things are already there. Some of them are thrown away. The oil palm leaves and fronts are thrown away as waste. Yes, it will take a lot of trees to reinforce and we're not saying you reinforce all the buildings with it, but if it contributes something to, and that's not the only natural fiber that we have in many countries, but it's going to contribute its own part to it, and you don't need to grow palm tree just for that purpose. The palm trees are already existing. You get this as a byproduct of another process, particularly agricultural processes.
Thank you, Dr. Israel, for that beautiful presentation. And you know, Dr. Israel has said we should start wherever we can. We started by asking questions and trying to clarify some issues. So I'm very sure that those of us in the housing industry, building industry, will start making use of all these natural materials, natural fibers that we have around so that we can really develop Africa. Thank you very much.
Thank you.
We want to have the last presentation. Is Dr. Damilola Oyejobi online? It's a virtual presentation. Is it online? IT? It's not online. Okay. Dr. Oyejobi is not online. Okay, he is. Okay, okay. So let's have him. Let's just give 1 or 2 minutes for him to. Okay. While he's getting ready, let me just read his. Is a young and dynamic Nigerian scholar based in Gabon, Botswana. He currently works with University of Botswana as a lecturer, researcher, and also engaged in activities. He holds his PhD from the Department of Engineering, University of Malaya, Malaysia. He's a professional engineer and member of American Society of Civil Engineers. He's a graduate member of Institution of Civil Engineers UK, and he's also registered with COREN, that's the professional body of engineers in Nigeria. His research interests include element analysis, structural engineering, properties of waste cell. You have 30 minutes for presentation. Thank you.
Right. Thank you. A very good afternoon, Chair, organizing, and to every of media presented for me. I hope you can hear. Can you?
Yes, we can.
Oh, okay, good. This afternoon, I will be presenting one of my graduate students with properties of waste size fibrous concrete with RHA for possible light traffic. That's my name, Damla, and who did the job is actually Abiona Cousin. This afternoon, the content to be speaking to, I think there is a we're using this afternoon is actually introductions. I will consider this selected literature review, materials and method, result and action. I'm going to conclude and make 1 or 2 on the work. Now, we globe are conducted in the large percentage of experiencing more. Now, once we're talking about precipitation, we're actually talking about the amount of rainfall the Earth surface is receiving. And in the last, let's see a lot of downpour, of which at the land mass with and the catastrophes even on the road, this big August, a lot of flooding. The top and area view of a state in Nigeria, to be precise, this happened in 2016. We can actually see the references of those pictures, and consequences are massive. One, there can be crop damage, there can be loss of lives, loss of properties, all the rest. Now, we may not be able to stop precipitation to take place. Of course, we know that this can actually be as a result of natural occurrence or at the same time as a result of the climate change, the human activity. And increasing precipitation is the application of pervious concrete in pavement design. Pavement is all about a colleague, or let me say a young fellow from the University of Ibadan who presented about Akure Road, talk about, and she made us to understand about flexible and the rigid pavement that we have. On the large mass, they can actually relate directly. So when we are talking about pervious concrete, is also known as a permeable concrete or porous concrete or no fine concrete. So it's a type of concrete in which there is a total elimination of fine aggregates. We know that concrete is actually a mixture of cement, fine and coarse aggregates, but this is a very special type of concrete in the sense that we make use of minimal level of fine aggregate, or we can actually eliminate it in totality. So once there is no fine aggregate, it means that such a concrete is actually characterized with large pores, because once you want to do your mixed ratio, you actually need to include the percentage of volume of oil that you want to be in your pervious concrete. So, and we all know that once there are pores, once the concrete is permeable, then there will be a reduction in the strength. So in this study, what we are trying to do, like, okay, I think I've explained this next slide talking about once you have your pervious concrete, is pervious, is permeable, water can actually pass through. So we have large amount of water on the surface. If we are successful in using it as a component of a pavement design, then the water can actually sink through. It can also in water recharge, and at the same time it has a lot of other benefits. So it also cuts down the cost of drainage, and this has been used and is sustainable. So in our own case, what we are trying to do is to replace the coarse aggregates. We know that the conventional way of producing pervious concrete is by making use of coarse aggregates and paste, cement and water. But we look around and we discover that there are a lot of waste ceramic tiles around us. Once a new construction is completed, we always have this huge amount of solid waste. That is one. Even after the demolition of buildings, or after the lifespan of tiles, then we remove those tiles and we dumped them. So we just want to see the possibility of reusing the waste ceramic tiles as coarse aggregate in making pervious concrete. So that is what this study is all about. And we said that it is being modified with RHA. RHA is nothing but rice husk ash that I'm still going to speak about. So this is only showing us the picture of what ceramic tiles is all about. And once we are able to do this, we will be saving our ecosystem, because we know that getting our coarse aggregate or even aggregate is actually capital intensive, is high, as in the cost of getting it is actually high, the energy is actually intensive, and it's not even environmental friendly. But these are waste products that we want to incorporate, so we'll be saving the ecosystem, and at the same time, we'll be reusing the waste products. Now, the aim of this paper was to study the performance of pervious concrete that contain 100% replacement of coarse aggregates with waste ceramic tiles. So that is what we have done. We are not just trying to replace it with 10%, 20%, but we look into the 100% and see what the performance will be. So in achieving this aim, we are actually more interested to see what will be the magnitude of our permeability coefficient. Because if it is a permeable concrete or a pervious concrete, then it should be permeable. So we want to see to what degree is this concrete is permeable. So that's the first objective. And at the same time, since there will be pores, there will be void in our concrete, we want to see how can we actually improve the compressive strength of our perfect concrete that is containing the waste ceramic tiles. Thirdly, we try to look into what to be the impact resistance of our perfect concrete. We want to see whether it will be good in resisting shock, load, and all the rest. And at the same time, for this study, we conclude by looking at the clogging tendency of waste ceramic tiles perfect concrete. Definitely, we know that the pores, the holes can actually get clogged, get modded with mud. So we want to say that if it is waste ceramic tiles, to what degree can the pores be filled with sediment and to provide solution to that. So I have selected literature review here. In 2017, Cartier and Fignes actually reduced the quantity of wax aggregate and they replaced it with marble aggregate. And it was reported that even though the permeability was reduced, but the strength was increased. There was another study by Berry in 2012 and another study by Shahar and Prida in 2014. Permit me to just jump this review, as we can actually say, even from the second literature review, that was 50% replacement. And the third one is actually 0% of fine aggregate. So, but in our own case now, we just take the study a bit ahead, and let's say 100% replacement and study the performance. Okay, the materials and method adopted for this work, we make use of granite for our control specimen. We make use of broken ceramic tiles. The sample is actually being shown on the right hand side. In our own case, it is one nominal aggregate that we used, because it has been reported in a study that once odd-in aggregate is used, the smaller aggregate has a tendency of filling up the void again, and we may not be able to achieve our purpose of permeability, or they can reduce the tendency of permeability. So we made use of an average ceramic tiles of 15 mm. What we did was that we did a sieve analysis, the one that passed through 20 mm sieve and retained on 10 mm. So that was what we tried to use. We made use of rice husk ash. Rice husk is actually a byproduct of rice, which we pre-treated, processed, and you can see the young man, they are trying to do the pre-treatment with hydrochloric acid so that to remove the particles and to make it fit for the job. So after the whole process, it was incinerated in furnace, and we are able to produce what you can see as the ash on the right hand side. Sorry. Also, we made this ordinary Portland cement of specific gravity of 3.15 and the great strength of 42.5 newtons, and we also made this of potable water. Okay, as of today, there is no standard for laboratory pervious concrete. We have a standard for the one of in-place pervious concrete, the one on the field. However, the National Ready Mix Concrete Association actually have a template that we try to follow. And what is most important when we are constructing pervious concrete is actually the ratio of glass aggregate to cement, unlike in conventional concrete in which it is water cement ratio. From the study, we know that once the water cement ratio is high for pervious concrete, since there is no fine aggregate, it's going to wash away the cement and there will not be binding. And if it is too low, the cohesion may not be there. But what is actually paramount is this cement, or let me say aggregate cement ratio, which it has been reported that it should be between the ratio of 4 to 6. So we play around that one and we have the control of this. And we, apart from the control, we have other three mixes that we look into. The mix one is actually 100% ceramic tiles with no addition. Mix two is 100% ceramic tiles, but we replace the cement content with rice husk ash by 10%. And mix three will also replace cement with 20%, but we kept the aggregate constant. So the major tests that we conducted were permeability tests, and the method that we follow was actually funnel head apparatus approach. We also considered the equation that you are seeing on the screen is actually a Darcy law that we use to calculate the coefficient, permeability coefficient in millimeter per seconds. So the A is actually the cross-sectional area of the pipe, the length is the length of the sample, the capital letter is actually the one for the sample, the T is the time for the water to flow from H0 to H1. We take note of the height, so we close the tap. As you can actually see here, this is not what we used, but a representative of what we used. So this selected area is actually our sample, and this is the tap. So what we try to do is that we take note of the height 1 and height 2, and we sellotape it so that the water will not actually flow out from the side. So we pour the water here, and we take note of once this tap was open, we take note of the time the water passed through, the time taken for the water to pass through from the H0 to H1. So that was how we calculated the permeability coefficient. We also looked into the component strength to see whether there will be any improvement by the addition of rice ash. We all know that it's a pozzolanic and it has cementitious properties. We also consider the impact resistance by making use of the hammer. This is the impact test apparatus that we used. We have a steel ball and we have a hammer that actually fall on the steel ball, and we try to calculate the energy absorption of the specimen to see that if such a thing is actually taking place in real life sense, to what degree can the pervious concrete actually absorb impact or shock. And lastly, we look into the clogging. So what we did was that when we are talking about clogging, it's all about the blocking of those entries, the capillaries. So what we did was that we made use of a percentage of fine aggregate. We just use 50 grams of sand to 1 liter of water. We mix it together, as you can actually see here, and we repeated the same permeability test to see the reduction in the permeability. So at the end of the day, the laboratory results that we got, we can see the radius, the cross-sectional area, the length, the time taken for the water to drop from one level to another. At the end of the day, even though this was represented in centimeter per seconds, control means add the coefficient of 3.14 mm per seconds, whereas the mix one, the one without a pozzolanic material, recorded 9.6, which was much higher than the one of control. And the one with 10% had a better permeability coefficient of 1.625 mm per seconds. And as we continue increasing the replacement of our RHA, replacing cement with RHA, we can actually see a drop in the permeability, meaning that some of the RHA blocked the entrances or the capillary for water to flow through. We went further by looking into the compression strength of our waste ceramic tiles pervious concrete, and at the edge of, we can actually see across the edge that there is an increase from 7 to 14 and down to 28 days. And excuse me, and at 28th day we got a value of 10 Newton per mm square. For Miss 1, the one having only ties, there was a huge reduction in our strength, 3.87. However, when RHA was included, we discovered that there was an increase even in the strength, meaning that it was able to bind our glass aggregates better than not having RHA at all. It was 10.8, and the strength was even much better at 20% replacement. From this, we try to compare it with what the limits it says in by NRMCA, that okay, the previous concrete needs to be between 3.5 and 28. And we can actually see that what we are proposing is within the range. Again, we went further by looking at the impact resistance test results. The NC is actually the number of blows to initiate the first crack. We have our specimen at the bottom plate of the impact test apparatus. We have the steel bar on top of it. So once we release the armor, the NC is the number of blows to initiate the first crack. We take note of when is the first crack was took place. So it took about 9 blows for the first crack to take place, and the final, and for the ultimate failure to happen, we all know about ultimate limit state. It was about 11 blows. It was 11 blows. So we used this parameter, and for our West ceramic tiles, it was actually the first blow that gave the first initial crack, and there was even ultimate failure. Although for Miss 3, it took up to 3 blows for the ultimate failure to occur. So we use this to calculate the energy absorbed at the initial and at the final. And finally, we try to use their parameters to calculate the residual impact strength. And those are the values that you can actually see. Again, we considered our clogging test results. So the second column was the result that we have seen before, of which we had the permeability before clogging. So we tried to flush out or to drain out our concrete, and we repeated the permeability, and the permeability after clogging, you can actually see the result, the reduction from 0.314 to 0.112 as a result of that clogged material that we used. And we calculated that, okay, to what degree was the reduction occur? You can actually see that for the control, there was almost 64% reduction compared to when it was not clogged. But for our waste ceramic tiles, pervious concrete, it's more than 80% reduction in terms of the rate at which our concrete was actually clogged. Yeah, it's fine, but there is a way out to this. So those are the 4 major tests that we consider in the laboratory, and based on these results, we are submitting the following conclusions: that waste ceramic tiles, fibrous concrete that contain 10% RHA, it has a strength of 10.8, which is slightly above that of a control mix. But when 20% RHA was used, there was an huge increase in the component strength of our concrete. So it can actually be a way to go by including the waste ceramic and RHA together and trying to solve the issue of the runoff that we may have by including it either as a pavement design or even in parking lots. 2, we say that WCTPs, that's waste ceramic tiles fibrous concrete, has a lower impact property with an impact energy of this 20.3 Newton meters, sufficient to initiate first crack, and it's very low compared to the conventional concrete mix. Although we may not be able to say what really went wrong, but we are saying that it can be as a result of brittleness of ceramic. However, this can be improved by making use of good quality ceramic mat. That can actually be a point because we made use of the old ceramic, although we determined the aggregate impact fallow. We carried out aggregate abrasion fallow, impact fallows, even before we did this test, and it was on average note. So we are now saying that if you can actually get good ceramic tiles, maybe it can yield a better impact energy. 3, we said that the water permeability of WTPC containing 10% replacement of cement by RHA is 1.625 centimeter per second and is 5 times higher compared to the one of control. So, one, we will be saving our natural materials and making use of the waste, and we'll still be getting a better result. And lastly, we said that WCTPC actually lose more than 80% of permeability after clogging when compared to the one of control. We are making these 3 recommendations that there should be an advocacy for the use of ceramic materials in concrete works, especially for pervious concrete, because one, they are actually beautiful, they are aesthetics, and at the same time to reduce environmental waste, and because of the mechanical properties that we have considered in this study. Again, waste ceramic tiles, pervious concrete should be used in an area with low traffic. We are not actually recommending it for the heavy pavement, but for low traffic, preferably for pedestrian roads because of its low strength and resistance to impact or sudden shock. And lastly, even if the clogging actually occur, we can use vacuum sweeper to clean off our fibrous concrete on periodical basis. So these are the selected references. Thank you very much for your time.
Thank you, Dr. Damilola Oyejobi, for that beautiful presentation. This paper is also on the use of waste materials. Since the beginning of the conference, we've been having papers on making use of waste materials. You know, there is this waste to wealth. The paper on, we had 2 papers on remanufacturing. It's also talking about reusing waste materials. So please, let's have questions for Dr. Oyejobi. Okay, 1. Any more? Yes, yes. There's only one person that has raised, that has expressed.
Good evening, Dr. Oyejobi. Nice presentation. I wanted to find out the clogging test that you did. Is it to any standard or is it original to this research? That is the first question. Then the second question was that, you know, this aspect of certain aspects of rice ash was presented earlier when you came in to support the earlier presentation. I just wanted to comment that the response to the size of the rice ash was about 300 microns, and that is quite high. If it's reactive, it doesn't have enough surface area to react. So I don't know if you can look at that. It should be between 10 to 75 micron, or between 20 and 200 square meters per gram, you could say, of a surface area. Anyway, those are my own contribution and my question about the the clogging test. Thank you.
Thank you, sir. Is that all? Can I respond to that question?
Please respond to that first.
Okay. Thank you very much for your beautiful question. Let me take it from the second question, talking about the size of our rice ash. If I am not making mistake, I think we pass our ash through 63 micrometer, not 360. I heard you, maybe you are saying 360. No, we passed, although we couldn't actually do the laser test, as in the automatic testing of analysis, but we arrange our 75 micron, 63 micron, and we now pass our ash through those set of assays, and it is the one that passed through 63 micrometer that we used for this test and for the higher paper. So that was one. Secondly, regarding the standard for clogging test that we carried out, like I said, I stand to be corrected. There is no standardized test procedure for permeability. Although there is a test by ASTM for in-place pervious concrete. That is the one in place, the one on the feed, the one that has been carried out. So there is an in-place test, but for the one in the laboratory, I think to the best of my understanding, there is no standardized procedure. So if we don't have it for permeability, then we were unable to actually get for clogging. So what we just use is just a laboratory setup. Thank you.
Do you have more questions? Okay.
Thank you, Dr. Damilola, for the presentation. Please, I just need a clarification still on the permeability issue. You said you used falling head method in the laboratory. And to the best of my understanding, falling head methods are used for cohesive, whatever, or if you are working on soil, cohesive soil, while the constant head are for porous materials. And since you are working on pervious concrete, I feel the constant head should be more suitable. Thank you.
Okay. Let me quickly, thank you for that question. I think it's another good question. I'm not a geotechnical expert, so I may not be able to clarify between either constant, I know of constant head, I know of falling head. So, and for our presentation, I said we only use the approach, the concept of falling head approach. And it's all about, okay, we have two pipes. You are actually asking for the clarification. I have my specimen this way, and I place my pipe on top of my specimen, and there is a base here and a tap coming out. So I took note of my H1, my height one, and the last point, the last H, and we just open the water to see when the water will go through. So that's why we call it funny head approach, just to study when the water will actually flow through. So I wouldn't know, maybe it's meant for cohesive samples in geotechnical aspect of engineering, but we only use that approach to cater for our own problem that we dealt with. Did I manage to answer your question?
Thank you. I think you've answered it to the best of your knowledge. Do you have questions? Okay, I also have a question. In your presentation, you said the waste ceramic pervious concrete is suitable for light traffic. How light? No? Is it for single axle, 3 axle? How light? I think
okay, thank you. Like from the recommendation that we made, we said for pedestrian walkways. So I think we are just talking about walkways, we are talking about parking lots, not for highways. Maybe if we continue this research, we can actually take it further once we are able to carry out the necessary tests that the pavement design needs to pass. But for now, we only recommended that, okay, even though for light traffic, parking lots, pedestrian walkways. Thank you.
Okay, thank you. Maybe you can also test for non-motorized traffic. Thank you. Do you have more questions? Dr. Damilola Ujobi. We thank you for your presentation.
It's my pleasure.
Through your email. Thank you very much. So this brings us to the end of our presentations in this conference. I think we have done well. We can appreciate ourselves. We actually had 8 presentations today, and I think yesterday in the day 1 of the conference, we had 8 presentations too, and day 2, it must be 8 too. So we have really done well in this conference. So I'm going to hand over to Dr. Francois to take over the closing part of the conference. Thank you very much.
My words are all about thanks. I thank everybody here for being with us to make this event happen. It would not have been possible without your presence here. So I thank all of you, and I really appreciate your time and effort, particularly the team. The members of the organizing committee who have been working very hard day and night to make sure that this event happens and is successful. Not only happening, but to make sure that the event is successful to the highest quality. So, and I would like to express my acknowledgement to students who are sitting here for making your time to be here, and I hope that you have learned something from the process. For students, this is a learning process. So I hope that you have been learning something that will be useful for you in your life after getting your degrees. So we have given you this opportunity so that you can be able to interact with the international experts in research. Okay, because we know that that is very important in your career, wherever you will be. Whether you decide to continue your studies at the postgraduate level, or whether you decide to go for professional career after getting your degrees. Last but not least, I thank from the bottom of my heart our guests from abroad who have tried all the best to make sure that they are here. So as all of you know, this is a hybrid conference. We have got people who are attending the conference physically here, and people who are attending the conference from their home countries. So the people who are attending physically, they have worked very hard for them to be able to be here. Can you please so traveling during the COVID-19 era is not easy. Traveling from Nigeria to Rwanda, Cameroon to Rwanda is not easy during the COVID-19. It's not easy. So that shows that they really have a very good professional spirit, okay? Because this is a research conference. They want to meet with international experts in research, build new partnership in research so that they can keep growing in research. So the ultimate goal is to make sure that we keep growing for sustainable development. So I really thank them for their presence. And because of that, we have prepared certificates for you, for us to express our thanks for us to show that we recognize your time and effort. So each of you will get a certificate. But because of time constraints, we are only going to issue 10 certificates here for our foreign guests, the participants who came from abroad. Then Rwandan citizens will get their certificates from the Central Secretariat. They are ready. If you can go there tomorrow in the morning, you will collect them from the Central Secretariat. So I would now like to invite the DVC academics, Deputy Vice Chancellor Academics and Research, to come and please help us to issue the certificates to our guests from abroad. Thank you very much. DVC, please welcome.
Good afternoon. And thank you very much. Thank you, Francois, for the floor. As you've heard, I'm not going to add many things. So we understand our guest foreigners will get their certificate now, while others will get their certificate as Central Secretary, as Francois said. So visitors, I think so the certificate now is for Folake Albuni Aktayo. You're welcome.
Well done, Farak. Well done, well done.
Akinwale Oladatun Koka. You're welcome.
Akinwale Koka. Ojerabi Adedokun. Okulora Olatunde. Chibuweze Aki. Taku Kumator. Lozebine Anyau. Yes, yes. Temitope Ayodere. Johnny Labilan. Okay, cheers. Agenda. Thank you very much, DVC, for helping us with this activity. We can go back to your seat, sir. Thank you very much. May you please have a seat? May you please have a seat? Summary. It's okay. So, there is a wrap-up. So, just take home a message, a summary, like a summary of what has been going on. I would like to invite someone who has prepared that to come and share that with us. Just a summary and recommendations from our discussion here.
So now it's time to summarize. So what we've been doing for 3 days. Okay, so the summary, it's about our conference. Of course, the theme was repositioning civil engineering education for sustainable development. So objective, of course, was to bring together a number of higher education institutions and industries in sub-Saharan Africa and beyond to discuss the latest research findings that contribute to enhancement of the quality of teaching and learning in the field of civil engineering. That's actually why we came here. And so the statistic, so we had the participant around 70, so physically and virtually. So that we had 28 presentations, so that was a very brilliant work. And so during the presentation, we covered the following areas. So water and environmental management, water engineering, civil engineering structures, and geotechnical engineering. And so we identify a lot of gaps and problems. Actually, we couldn't find solutions. So, and some of them, of course, we try, and we will, of course, continue to work on them. So there is exploration and management of groundwater, and adoption to remanufacturing products, soil erosion and flood management, and the failure of asphalt bridge joints, linkage between practices and theory in civil engineering education, and use of prefabricated structures for rapid supply of building structures, reuse of waste civil engineering materials. So, and we had less female in civil engineering career, and less performance of construction materials. And of course, we had opportunities and challenges. And we had the mindset of end users of civil engineering products. And we had international research exchange. So I think we had a lot of research across the globe. So, and then we have lack of research data. So in some research, actually we were limited to the data to back up our research. And we have also the partnerships, okay? And so the commitment. So what we, as the researchers, lecturers, and so we commit to encourage females to join the civil engineering career, and to match the theory and the practice in the civil engineering education. So to improve ongoing research based on the comments from the participants. We're given a lot of comments and actually were very helpful because one head cannot think about, so many things at the same time. So to apply problem-based learning approach in civil engineering education. So we have to set up problems and we see now step to how we can solve this, to engage students to be able also to how to solve the problems using using like a technology they learn in civil engineering area. So and then we provide the recommendations. So first goes to universities. So to involve students in research for future researchers and to encourage students to develop, to do problem solving research, okay? And to motivate researchers and the lecturers. So for example, university can provide incentives or whatever, but it's just a motivation, okay? Because research is something which is very important, but when you see what comes out of as money, it's just nothing. So we work for the society. So, and we have to reinforce partnership with other universities and institutions, okay? And also to increase research funds, okay? So we should get more funds to do this kind of research. And also to organize more international conferences like this. This was a very nice chance, okay, we had. And to upgrade the curriculum, referring to the need of industries, institutions, and academia. All of those three areas should work together, okay? And we recommend also to the governments, so to increase research funds, of course, and also to consider and implement research outcomes, and to encourage researchers to mitigate, identify the gaps and the problems, okay? And the last recommendation we made for industries, just to work closely with universities and the research centers. We know the industries, they have what you call research and the development area. So in that, through there, they can work with the universities, then we can do like a good research that can help our community. So thank you very much.
For helping us to wrap up our discussion. So it is important that we do not spend 3 days here and we go home with nothing. It's important to have a take-home message, something to go home with. So that is important. So with this, I'm now going to, as you know, this event could not have been I'm sorry? This event would not have happened without financial support. Where did we get funds from? We got funding from Royal Academy of Engineering, UK, in London. So it is important that we always thank them for making this event happen, this event possible, because without money you won't be able to do anything. So the money comes from Royal Academy of Engineering in UK, and it is provided by the UK government through the Royal Academy of Engineering. So as we celebrate our success in this event, it is important for us to celebrate with them. It is important for us to invite them to come on and celebrate with us. That is the reason why I'm going to invite you to invite someone from Royal Academy of Engineering to come on and say something about this event. Thank you very much. Katrina, if you are available, please come on. Thank you. IT team.
There I am. Hello, can you hear me in the audience?
I am not going to introduce you, but I'm going to give you an opportunity to introduce yourself to the participants so that participants can know who is speaking. Can you please first introduce yourself? Thank you.
Yes, of course. Can I check that you can hear me?
We can hear you. Please go ahead.
Okay, perfect. Thank you very much, Francois, and good afternoon, everyone. My name is Katrina MacArthur, and I am Programme Manager at the Royal Academy of Engineering in the UK, working on the Academy suite of Africa programmes. It is a pleasure and an honour to be with you here today. And firstly, I would like to express my thanks and congratulations to Francois Nsengiyumva and the team at Ines Ruhengeri on a very successful conference. It's been very clear from the varied and highly engaging agenda of presentations that a lot of work has gone into making this conference happen. And we are pleased to see the many positive interactions and knowledge creation that this event has prompted. At the Academy, we bring together the most talented and successful engineers to drive excellence in engineering for both the benefit of society in the UK and across the world. The Academy is the founder of the Higher Education Partnerships in Sub-Saharan Africa programme, also known as HEPSA, of which Ines Ruhengeri participates as a hub university. So for a bit more background, grants are awarded to higher education institutions in Sub-Saharan Africa to form and strengthen partnerships with industry in order to enhance the quality of engineering education. This conference, as you will know, is part of a wider project led by Ines Ruhengeri with the support and active collaboration of the Catholic University of Cameroon, the University of Ibadan in Nigeria, the University of Botswana, and the University of Aberdeen as project partner in the UK. And I'd like to give my personal thanks to all of the partners involved in this project. As you know, this project aims to strengthen academia-industry ties and promote further research in civil engineering for food security in Sub-Saharan Africa, better known as the SICE Africa project. I'd like to acknowledge the challenges of these past 18 months. I know it's not been easy, and the original plans for this project have not been able to be implemented as you may have originally envisioned. But I want to follow that by saying congratulations on successfully completing this project despite the challenges that you have faced. As part of this project, university staff have carried out secondments into local industry, and industrial secondees have had the opportunity to come to Ines Ruhengeri in order to strengthen academia-industry ties. Secondments are a vital part of the HEPSA programme, and this has been a clear strength in this project. Secondments promote best practice, nurture collaboration, and increase local engineering capacity to meet the needs of industry. Academia-industry linkages have also allowed students to enhance their practical skills and, as a result, improve their employability opportunities. It's been great to see how the SICE Africa project has successfully prompted knowledge transfer through cross-disciplinary and cross-university joint research and learning workshops, recognising and celebrating the key value of collaboration to push boundaries into new directions and provide innovative solutions to local challenges. The topics discussed during this three-day conference are hugely important for the engineering profession and for our society as a whole. To develop more efficient and cost-effective engineering solutions, it is crucial to support engineering innovation and enterprise as arenas for improvement and sustainable development. This conference has reflected on the importance of sustainability-focused civil engineering innovations and research, and the many challenges that nations face in this regard. Many presentations have focused on the need to overcome the challenges posed by the high costs of building materials and the need for more sustainable and cost-effective alternatives. As mentioned during the conference, the Rwanda 2050 vision and the continent's commitment to sustainable growth emphasizes the vital role that engineering plays on the path to sustainability and growth. Continuing this line of thought, knowledge sharing serves as a foundational pillar for the promotion of value creation and best practice for sustainable civil engineering. Initiatives like this SICE conference enable knowledge transfer, allowing participants to share lessons learned and build stronger engineering networks to advance locally led development and research for the delivery of new products, services, and enterprises that generate jobs and value to society. Engineers play an active role in building an inclusive and sustainable society, and their work has a direct impact on people's lives. Engineers act as enablers of systems and solutions for the sustainable use and management of natural resources and processes involving manufacturing and construction. At the Academy, we place emphasis on supporting systems and networks that allow wider societal responses to sustainability challenges. We believe that engineers are influential agents of change and drivers of economic opportunity, and we are thrilled to be able to support the strengthening of the profession in the continent through accelerating research and technology transfer opportunities. As highlighted during this conference, advancing gender equality in engineering is a key driver in the creation of sustainable capacity and the development of a highly skilled workforce. I'd like to congratulate the organisers of this conference, particularly on the level of inclusion that has been curated. This has been one of the best hybrid events I have attended. I've taken photos and screenshots to share with my colleagues, and I think it's been done very well, so congratulations. It's also been great to see the opportunities that have been given to younger students to present their findings and gain valuable experience in the field, benefiting from the support of the community. The civil engineering sector plays a pivotal role in building a more sustainable future, and we've been delighted to see firsthand the transformational power of collaboration, and during this conference, but also throughout the development and implementation of the SICE Africa project. So I'd like to just finish by saying thank you again for everyone's participation and insightful contributions in this conference. As an academy, we look forward to continuing to support engineering excellence and technology innovation in sub-Saharan Africa, harnessing the power of engineering to build sustainable societies and inclusive economies that work for everyone. Thank you again, and I'm very happy to have this opportunity to celebrate with you. Thank you.
Thank you very much, Katrina, so for your interesting closing remarks. So with this, we are coming to the end of this event, but we are not ending now. We are now going to celebrate. So, so we are going to celebrate and hope that you will keep celebrating with us. So we are going to have a session for traditional dancing. So the Rwandan dancing. So and I hope that Katrina also will be able to see some dance, some traditional Rwandan dancing. So Katrina, if you can please be on maybe for 10 to 15 minutes, that will be useful so that we can celebrate together. So I'm going to invite traditional Rwandan dancing to come and celebrate with us for this successful event. Thank you very much.
Yeah, yeah, ah, yeah, yeah, ah, yeah, 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 yes, mundu, ah, yeah, yeah, ah, yeah, ah, yeah, yeah, yes, mundu, impundu mwiza agira amararo nanjye ngira amaramuko dore aho twataramye ntaro yehe ingese mpundu we ye aye ye aye aye yehe yehe ese mpundu we impundu gira amararo nanjye ngira amaramuko dore igisubizo aho twataramiye haziriru dushimunda kuvugiza ngarusha ko tabikone niko rafasa ndumucarugo mu Rwanda yego ikundi nkindu umuco w'abanyarwanda tuwusakaze hose we inkindi mwizihira baraka rero n'inkindi turatarama dukeshe cyane inkindi turaneza baraka we ndatusokoze hose we inkindi mu bikoresho gakondo shenge inkindi harimo ingoma mureba inkindi harimo n'imirishyo shenge inkindi utibagiwe imikenyehe atusokoze hose we n'inkindi turatarama dukeshe rero inkindi turaneza baraka cyane inkindi kandi ntigira ubwoba we abanyarwanda inkindi mu bahanzi b'u Rwanda rero inkindi harimo Mariya Yohana inkindi hakaba Masambi Intore inkindi utibagiwe Muyongo Rwanda tusokoze hose we n'inkindi turatarama dukeshe cyane n'inkindi twizihira barahashenge inkindi kandi ntimugire ubwoba tusokoze hose we inkindi umuco wacu urawukunda ntabaza njyewe natabaje imazi ntabaza njyewe ndabatabaje yewe nyangufi mu bakungu mumumpamagarire yewe songa imena uruyego muyimpamagarire ngiye inkase nayanyoye ngiyo mbuzi nzovuma uje mbamvuga ibi birezi by'urwagasabo vunje mbamvuga batarutinya shenge inzovu ze izerade nk'inyange ma yemuro kumuyiro werutonde kungeri yaruhin ingoyi bawe onavo yehe kumuyira urutare rwiza noteragaho izuba rikarasa rikarenga ebanga urutare rwiza n'urutare gisubiye ebanga urutare rwiza twizihira baraheye ebanga urutare we teragaho izuba rikarasa rikarenga njyewe nkumbuye rebanga urutare rwiza n'uyu muco gakondo ye ebanga urutare mvuga twizihira barahaye ebanga urutare we rwiza noteragaho izuba rikarasa yehe njyewe nkumbuye ebanga urutare rwiza twizihira barahaye ebanga urutare we oteragaho izuba rikarasa rikarenga njyewe nkumbuye kurureba gaduce mbunda kuvugiza karuci kota gukeba ndindi kuri bavuza n'umucaro Rwanda w'u Rwanda biruta kubana abahinduriza mu Rwanda cyakara n'ibya bakonje bakonje yagoshe seruka mu yagoshe kuri gikate katurije cyose ni muri biryashiramo yagoshe Yagos. Yagos. Omurakumbura igitego gisubizo nkunda. Yagos. Yeah. Ngwinurare ngwinuraye nurare nanjye nararaye ngwinurare moze turaharaye nurare wiwe ngurare nurare nanjye naraharaye nurare nimuseruke gitoriye nurahiye ngwinuraye nurahi nanjye nararaye nurare nanjye nararaye ngwinurare mbarushikirihingo we mbarusha gusheja abakobwa biwacu ngibako w'inka nyinshi abako w'inka nyinshi umva ngo ndaje cagawe 18 18 chagawe ni nyana zazo we ha inka we meri inka we ha inka we inka we ha inka we ye inka we ye inka we ha inka we ngo reka ndatuwampaye inka we yayimpaye haruguru kwishyambuga n'ubwirire bisobamereza inka n'amajana ng'inka we ye inka we ye inka we ha inka we ngo ntukansige kana kajya kurenga haruguru mwishyambuga n'ubwirire rusobe rwuzuza inka n'amajana ng'inka we ye inka we ye inka we ha inka we meri inka we ngo nagukumbuye kuwa kane kuwa gatanu ndakwandikira ngidamutso naguhaye niyeza kuzwehe ng'inka we iye inka we iye inka we ha inka we iye go we izahiye iye go we bagabo muri mugakinga turi inyange ruganira bakobwa muri mumberaho muri inyange ruganira wansabira we wansabira kayama ngize nti muri abahungu muri abakobwa murabyemeye ye nyirahinga yemwe we yemwe rero ntunkorere ku mabano utanyanduriza yewe umuheto ngiyemwe rero yemwe we yemwe rero we munywanyi wanjye habyina ikibindi naho mwebwe muri kubeshya yemwe rero bari barashwanye none amasaka arabunze yemwe rero yemwe we yemwe rero we rero mbe munywanyi wanjye ntunkorere ku muheto utanyanduriza burya amabano dore ayo mabano nyitabana mu nkiko z'urugo yemwe rero ntunkorere ku mabano utanyanduriza umuheto nkwitabana mu nkiko z'u Rwanda yemwe rero ibari barashwanye none dore burya baranywanye musohoke gitore maze mwiyereka baraha yemwe rero yemwe munywanyi wanjye ntunkorere ku mabano kandi ntunkorere ku mabano utanyanduriza umuheto wanjye yemwe rero
We are still celebrating. We will keep. When do you want to stop? When do you want to stop? Next week? Or next year? Yes, good. So we will keep celebrating. But in order for us to enjoy more, we are going now to change environment. We are now going to celebrate from a different environment. Okay? So we will keep celebrating, but from a different environment. Okay? So thank you very much for making it happen. So we are now going to board the buses. There are buses here in front of this hall. So the buses will take us to a very beautiful place. Okay? The buses are going to take us to